Good morning, all. It's great to see you. If we wait another few seconds, there are more people joining, and then we can start. In the meantime, maybe you can say hi in the chat and from where you are joining us. That would be great. Hi, Rajesh.
It's nice to see you all.
Hello, sir.
Hello, how are you, Rajesh?
Yeah, I'm fine. How are you?
I'm quite well, thank you.
Oh, great.
Okay, I
Hello,
think we can.
everyone.
Hello. Adam Sahamid, how are you?
I'm fine. How are you? Thank you. Thank you.
Good. It's great to see you here.
So our Cameron Petty is back after the marathon.
I'm here. Oh, yes, you see.
Wonderful seeing that.
Well, the photographs where I look very tired.
Yeah.
Okay, I think we can start now, and people are slowly joining us. So hello again, and welcome to our workshop, Historical Maps, Documents, Archaeology, hosted by the Mapping Archaeological Heritage in South Asia, MAHSA, and Mapping Africa's Endangered Archaeological Sites and Monuments, MAEASaM projects. We have people registered, I think, and joining us from about 25 different countries. This is great, and it wouldn't have been possible if we had an offline meeting or workshop. So it's great to have you all here with us, and we hope our third in the series of online workshops will again provide an opportunity for all of us to engage and connect. And my name is Azadeh. I'm the training coordinator and research associate for the MAHSA project at the McDonald Institute for Archaeological Research, and I'm very happy and pleased to be your host and moderator today. Before we start, I wanted to say that, as you know, that this meeting or this workshop is recorded, so we're recording the workshop so we can use the video for the people who couldn't join us, and also for yourself to have it on our website as a workshop material. I'm trying to. Okay. Without further ado, I wanted to invite MAHSA's project's principal investigator at the McDonald Institute for Archaeological Research, Dr. Cameron Petty, and Dr. Faye Lander, MAEASaM's regional project manager at the University of Witwatersrand, to start the workshop by welcoming you all here. Cameron, if you can start now, it would be great.
Thank you very much. Thank you very much, Azadeh. It's so wonderful to see so many people joining us. This is a very exciting opportunity to engage in a type of interaction. We recognize that we are all still in the middle of a pandemic, but this is the sort of thing that would have been very, very difficult in the past, was actually speaking to so many people at the same time. And we're now actually able to engage with you in so many different locations, so many different time zones. We thank you very much for either being up early or being up late, or whatever current circumstances you're in. I'm speaking on behalf of the Mapping Archaeological Heritage in South Asia project. There'll be also a brief introduction from a sister project as well, but it's so great to see our people that are already collaborating with us on the project, people that may come to collaborate with us coming forward. We're really looking forward to talking to you today about some of the approaches and methods that we use, and giving you some broader insights into the work and its potential. I don't want to take up too much more of the time at the beginning, but I'd just like to say thank you all very much, and I look forward to speaking to you more shortly.
Thanks very much, Cameron. And Faye, if you can have the floor now.
Greetings, everyone, and welcome. It's amazing to see everyone here. I can't believe how many participants we have in this workshop today, esteemed guests and colleagues. So just about myself, I'm Faye Lander. I'm the regional project manager for Southern Africa for Mapping Africa's Endangered Archaeological Sites and Monuments, otherwise known as MAEASaM, and our project principal investigator is Professor Paul Lane, based at the University of Cambridge. And very excited to have this workshop. First and foremost, a special thanks to the organizers of this workshop, particularly Azada, for bringing everyone together. And let's hope it's a successful one. Thank you very much.
Thank you very much, Faye. So I want to start this workshop and introduction session with a poll. Let me start the poll so you can fill it out when I talk. So this is the first one, launch. So you should be able to see it. So this is mainly a couple of questions, only two, and it's mainly to help us to be able to assess the impact of our workshop, because kind of question to understand what is the knowledge of the topic that we're presenting today before the workshop starts. And also I'm going to ask the same questions after, so we can use it as a way to see how our workshop was successful or not, and be able to make our future workshops better. So if you can all answer these two questions, and I can give you a minute, let's say, to get your answers, that would be great. And I'm not going to share the answer. This is just for us. So feel free. Thank you. Most of the people have answered. Just I'm going to wait another few seconds before stopping the poll. Okay. Thank you very much. Thank you again, and thanks for participating at this poll. And thank you again for joining our third workshop, Historical Maps to Document Archaeology, in our workshop series. The main aim of our workshop series is provide an opportunity to share knowledge with our stakeholders by way of introducing different technologies and methodologies that we use at our projects to identify and document sites, understand the landscapes of the region that we're working at, and monitor condition of the sites over time. For those who have missed our previous workshop, don't worry, as they are accessible on our YouTube channel. We had our first workshop on remote sensing in archaeology in December 2020, if I'm correct, and the second one on databases and their use in storing, managing, and researching archaeological data, and that was in May of 2021. I'm gonna share the link here of our YouTube channel where you can find the videos, and when this video for this workshop is ready, we will also add that to our YouTube channel. Please subscribe to our channel, and you can explore and watch the videos at your pace and leisure, but don't leave us now. Stay here as we got plenty to present today. For our today's workshop, we are covering another theme that is part of our project's workflow, and that is use of historical maps in archaeology to map and document archaeological features. And this is also one of the subjects that we have been asked from our previous workshops by our attendees to have a session about. Historical maps provide an important source of data for landscape archaeology to help and understand past landscapes and distribution of possible places of archaeology or heritage importance. These maps usually record enormous amounts of information, and it also includes either intentional or accidental documentation of archaeological heritage. Their use is complementary to satellite imagery. The earliest satellite imagery are dated to the second half of 20th century. However, these maps, the historical maps, if they're available for the part of the region or the regions that you're working on, they're dated to much, they could be dated to much earlier date. And they provide a unique documentation of the landscape before major urbanization, agricultural and industrial development have disturbed the land. With today's workshop, we want to share with you how in our projects we use these maps. Our speakers for today's workshop will talk about the context and background of historical maps in South Asia for MAHSA project and in Africa for MAEASAM's project, where to look to find give you information on where to look to find these maps, what to understand from the map, and the various systematic methods and analysis to use on the map to identify and detect possible sites and provide any useful information to better map and document them. We will present the georeferencing techniques that we're using for our projects to locate these sites and the accuracy and also inaccuracy in some cases of these maps. And we will be introduced to the machine learning and the automated detection techniques that's been used in archaeology to automatically detect archaeological sites from these maps. I've shared the program of today with all you all, and I can add this also in the chat. We have 5 different presentations, but by our MAHSA and MAEASAM's team about the mentioned subjects. And I'm very pleased to be joined by our speakers today, and I'm going to ask them maybe to turn their camera on and say wave and say a hi. So we have Cameron, Junaid, Jack, Afifa, Ed, Rainier, and Iban here joining us. A note that I wanted to say on our Q&A session: whenever you have a question while the speakers are presenting, please type in your questions in the chat box, and at the Q&A sessions I will call out your name and you can either unmute yourself and turn your video on if you like to read out loud your question, or if you prefer, I can do that and the presenters can answer those questions. If there are any questions in the chat box that we couldn't answer in the time slot that we have, we will answer them, and then we can also share those answers with all of you after. Our workshop are designed to be more like webinars. So our speakers, they present, and we have also these Q&A sessions for a bit of interaction, but it's not designed to be a fully interactive workshops. We will having specific and more tailored tailoring sessions with our collaborators, which those will be our more interactive sessions. And these workshops are more like introductory sessions for our trainings as well. Before handing over to our first speaker, I wanted to say that I will be monitoring things in the background, and if there is any issue, you can raise your hand and either type in the chat box. And there is a new functionality with the reactions in Zoom. There's something that says that slow down. So if you think that people are talking fast and you want them to slow down, you can use that reaction as well. And I think I wanted to say this at the beginning, but I think I forgot to say, or did I say that the workshop, as you know, is recorded, and we're going to take screenshots for our social media. So I think now I can present our first speaker of the day, and he's been already introduced, Dr. Cameron Petrie, the principal investigator of the MAHSA projects and the reader in South Asian and Iranian archaeology at the MacDonald Institute. He's going to talk to us about the Survey of India historical maps, the history behind this map series, and with a few case studies, he will present a range of information we can understand and identify from these maps, as well as the challenges and opportunities. Over to you, Cameron. Thank you.
Thank you very much, Azadeh. Let's just make sure I get this right. I'm just going to do this. Looks like we're sharing. Excellent.
Yes.
Very good. Okay. Thank you all very much. So I just I'm starting off this presentation by actually showing you a historical map from the outset. And I'll be showing you many more maps as I progress. And as Azadeh pointed out, this talk is designed to be a bit of an introduction to the concept of historical maps and their use in archaeology more broadly. But what you can see on this particular map, this is a map from the very early part of the 20th century. And this is actually, in many respects, a very beautiful object in and of itself. It's a map that was designed and executed as part of an imperial mapping strategy. But it documents a landscape in a very specific point in time. And interestingly enough, much of these landscapes are familiar in the modern world, but they also have undergone quite a dramatic amount of change in the last 100 years. But importantly, these maps contain, just from their nature and the nature of the methods that were being used when the original surveys were undertaken, they contain a lot of information that is interesting and relevant, either from an archaeological sense or from a heritage sense. And researchers working in different countries in South Asia over the last 50 or 60 years were aware that these maps contained information, but there'd never really been any systematic attempts to document that information. So a series of projects that was started in collaboration between the University of Cambridge and Banaras Hindu University in India, namely the Land, Water and Settlement and the Two Rains projects, and most recently the Tigris Project, have all set out some of the foundational work that we're now building on in the Mapping Archaeological Heritage in South Asia project. And many people that have been involved in this work are actually in the virtual room. So I'm just saying a welcome and a hello and a thank you for all of your work and support, particularly my collaborative co-director, Professor R.N. Singh. And I hope this will give a good explanation of the history of the work overall, but also a little bit of an outline of the type of work that we've been doing as well. So there's a considerable history of archaeological research that's designed around trying to reconstruct settlement landscapes and using the principles of landscape archaeology to try and understand how humans lived in particular landscapes, where they lived, and how those sort of dynamics changed over time. And this sort of work has been conducted in various regions around the world, especially in parts of the Middle East, Western Asia, parts of Iraq, Syria, the Levant, etc. There's also been quite extensive work done in the Americas, for example. And what has become clear from these sorts of approaches is that by looking at archaeological data as it appears on the ground, it is possible to reconstruct what people refer to as signature landscapes, so distinctive types of approaches that were used in the past to live in particular locations. And these can be revealed by looking at archaeological data systematically. Now, there's been various approaches that have been used to identify archaeological sites. And in many ways, archaeological survey and landscape analysis has benefited enormously from methods that make it possible to work remotely. And interestingly enough, these methods are also in some ways very well suited to a period where it's quite difficult to go and work on the ground. So most specifically in the last 20 years or so has been a considerable amount of work making use of declassified Cold War satellite imagery, whether they be satellite photographs or aerial photographs and various sorts of other types of resources. And as you can see on the top left-hand side, due to the nature of the Cold War and the powers that were in play at that point in time, actually quite large parts of the planet are actually covered with reasonably systematic satellite imagery that was documented, particularly in the 1960s and 70s. Now, what's interesting about these images is that they often collected information on regional landscapes that are now lost, but due to factors like development or remodeling of the landscape, urban development, and various sorts of other aspects. But we have a vast range of material that has been used quite systematically in archaeological explorations in various regions. Now, what's interesting about working in a region like South Asia is that we do have extensive evidence for important archaeological heritage and archaeological history, particularly in the region of the Indus River Basin, which spans across the regions of modern Pakistan and also India. Now, we know that this is one of these great old world civilizations, regions that were dominated by the developments of early cities and early complexity. It was broadly contemporaneous with what we know occurred in Mesopotamia and Egypt. And there was a sort of a rise of urbanism and ultimately a decline of urbanism, and then a sequence of subsequent changes that occurred. Now, what's interesting about the archaeology of the region, the Indus River Basin, is that we have a very specific type of settlement archaeology that is in play in this earliest phase of urbanism. We actually have a number of very large cities, but importantly, there's actually only 5 known settlements that are in excess of 30 or 40 hectares in size. So this is quite interesting in a sense, because it does suggest that urbanism was an important feature of the Indus civilization, but also that it was relatively uncommon in the sense that a very high proportion of the population continued to live in village settlements. So if we're going to understand this ancient phenomenon, we actually need to look at the cities, but we also need to look at the settlements that existed in between these cities, the types of landscapes and settlement hinterlands that existed. And in order to do that, researchers for many decades have been involved in trying to identify archaeological sites on the ground. And there's an abundance of archaeological surveys that have been carried out, a range of attempts to collate the archaeological evidence together. There's been a numerous instances of publications that have either published primary research or collated that primary research together into large gazetteers. And those gazetteers have resulted in maps that look very, very convincing, and they show the distribution of archaeological sites across large areas. However, work that we've started to conduct in the last 5 years, which is building on work that started earlier, has been able to demonstrate that our knowledge of the archaeological information is actually quite skewed, and it's a little bit specific, and it focuses on, perhaps inevitably, the areas that have been surveyed have led to the production of the most amount of information that we have on archaeological site distribution. So this suggests that there's probably a lot more information that's there to be learned, a lot more archaeological and heritage sites that are out there. And this has all sorts of implications for understanding archaeological aspects, but also aspects of heritage and preservation and documentation and monitoring of those sites as well. So what we did starting in 2008 was to conduct a series of reconnaissance visits and surveys to try and understand the nature of the distribution of these sites. But also in the background, we were trying to set out the right sorts of methods and discovering new approaches to enable us to identify sites in a systematic way, but also as quickly as possible. So the initial surveys that we carried out starting in 2008 led us to a series of realizations. Now I'm going to illustrate these realizations actually with giving you some hints in the background of showing you some examples of historical maps, so you can see the implications of what it is that we're actually showing. So a number of these gazetteers have been compiled in the last 20 or 30 years. And these gazetteers list the locations of archaeological sites. They also list the periods that archaeological sites were actually occupied in. Now, one of the things that we realized in 2008 was that when we went to try and visit sites at the locations that were listed in the gazetteers, most typically the sites were not in the same location as the location that was listed. In some examples, the locations were out by considerable margins. So this is one specific example of an archaeological site that's actually 11 kilometers away from the listed location. Now, this is interesting historically for what we can learn about why that has happened. But if you think about it think about the implications of that discovery or the realization, we can actually see that unless we know accurately where the archaeological sites are, it's very difficult to monitor them as a heritage resource, but it's also extremely difficult to analyze those sites in relationship to the landscape contexts that they're sitting in. So it's only really when you actually get an accurate assessment of where a site is located in space that you can actually use that information for any particular means. Another realization that we made quite early on was that there were actually a relatively small number of sites that were located along the courses of modern rivers and channels. It seemed as though a substantial number of sites were actually located perhaps in association with older or ancient and now vanished river courses. But it was quite clear to us that there had been a significant change in the structure and the hydrology of the landscape. And that was quite telling as well. The third and the fourth major realizations were connected to something that I've already alluded to. One of the things that became very clear was when we started to map the location of the known archaeological sites, and then we mapped the extent of the specific surveys that had been undertaken. It became quite clear that the vast majority of sites that were known because they were in areas that had been surveyed, and we had relatively little information about areas that had not been surveyed. That may seem sort of, completely obvious in many ways, but in the end, perhaps our knowledge of archaeological information is an accumulation that's built up over time, and people have documented archaeological sites in all sorts of ways and means. And the phase of carrying out archaeological survey in some respects is actually one of the most recent periods of discovery and documentation. But it's important if we think about the fact that we learn a lot on the basis of where we look, but if we don't look in certain areas, we then really don't know what is going on in those areas. So in the end, if we build up arguments about the number of sites or their distribution, based on patches of information, we end up with only a patchy explanation of what it is that we're actually looking at. And that is in many ways a problem. And the final realization was very much the case is that it was recognized that although we discovered hundreds of sites and that we knew hundreds of archaeological sites, there were actually probably many hundreds, if not thousands of archaeological sites that were out there that had not actually been formally documented. It's almost inevitable that these archaeological sites are known by local populations, local farmers, local communities, but they're not in formal registers of archaeological heritage and listings. So this is a problem in many ways. And we were asking ourselves from the very, very beginning of our archaeological research, particularly in northwestern India, what are the steps that we need to go through to resolve these problems? Now, in part of that process, and this is something that led us to build up systematic methods of trying to resolve these problems, part of that came about from the fact that even before we conducted the surveys, we made copies of historical maps and took them with us into the field.
Oh, yeah.
Because we were aware that these historical maps were useful. And in some ways, we didn't quite know why these maps were useful and why they were significant. What we've done in hindsight actually is to retrospectively go and have a look at the history of the mapping that has been carried out as part of the Survey of India in the 19th and early part of the 20th century particularly, and therefore giving ourselves the opportunity to understand why these archaeological sites, heritage sites and features were being documented deliberately, as Azadeh pointed out, but also why they were being documented effectively accidentally. And that was not necessarily a part of the original plan of the survey that was taking place. But what we have actually as part of the Survey of India work, particularly the maps that were produced in the early part of the 20th century, were extremely high resolution illustrations that show us features on the ground. Often they are mounds. Often they're mounds that are no longer occupied, and they have distinctive shapes in the landscape. And basically, this is the outcome of this progressive move during the period of British control of South Asia was to survey the landscape and to document it systematically. Now, the survey of India set out in the 19th century, actually starting even earlier, to establish a trigonometric survey across South Asia. They attempted to document the landscape, to conduct analyses that enabled them to measure the heights of the Himalayas, for example. But they also engaged in surveys that there was assessing trigonometric aspects, measuring the curvature of the Earth, because the size of the subcontinent was so much larger than the British Isles. It actually made it possible to make mathematical calculations for the curvature of the Earth. But in addition to that type of, in many ways, scientific information, there was complementary surveys that were carried out that took analysis of the topography of the landscape. And these were also combined with revenue surveys, which were designed to make an assessment of the economic output of farming land and the landscapes. Now, these surveys were carried out over many, many decades, and they were inevitably carried out progressively, so small, one region at a time. So there are many maps that have been published that show the progress of these surveys over time. And so this map is an illustration of the progress of various surveys of different types. The topographic surveys on this illustration are shown in green, and the revenue surveys are in red and pink, showing the intensity of the survey and the work. And then what happened subsequently in the early part of the 20th century was that there was a specific move to actually publish the outcomes of these surveys. So we saw the combination of the topographic and the revenue survey information and the progressive, gradual publication of these map series over time. And the Survey of India published map sheets that show the progress of the surveys and the degree to which they were resolved at different points in time, in real time. Now, what was interesting about this program of survey was that there was actually a recognition as the publication work continued that there was all sorts of information that had actually been documented as part of the original surveys. So what you can see in this illustration is two different examples of surveys that were, legends that go with the survey maps. And you can see there's a considerable degree of focus on the type of infrastructure that political agents would have been interested in, where the railways are, where the roads are, where the springs are, where the forts, where the religious sites and monuments are, where the post office and telegraph offices are, boundaries, geographical locations, and those sorts of features. But in addition, many of these maps also documented information about the landscape that was sort of hidden in the background, the types of topographic features like riverbanks and the movement of river channels, the appearance of water tanks and whether or not they held water or did not. But importantly, as you can see in the rectangle shown in blue on the lower one of these legends, there's also the documentation of settlements. Now, what's interesting is that in addition to the documentation of settlements that were actually being occupied, these surveys also assessed whether or not settlements had walls.
Not yet, baby.
Whether they had
Cameron, you need to unmute yourself. Thank you. Sorry, I think the mute all button was pushed. Yes.
Sorry about that. Yeah, so whether the surveys were assessing whether or not settlements were occupied, whether they were deserted, and they also documented whether or not a site was a known ruin as well. And that was marked in a specific sort of Gothic script. Now, what's interesting, therefore, is that the surveyors themselves were actually recognizing unusual things on the ground. And they used specific symbols on the historical maps to document these unusual features. Now, what you can see on the lower right-hand side is the number of features that are visible on a relatively small area of one of these historical maps. The numbers relate to the feature type. So there's features of certain sizes and things. And the features that we've started to document systematically starting as part of the Two Rains project, continuing through the Tigris project, and now as part of the MAHSA project, is to systematically document these different features. So some of these elevated features appear to be shown as stippling. Some of them are shown as an incomplete contour line, which is called a form line. And some of them are shown as with hatches. And we know from our knowledge of the archaeological history of the subcontinent is that people lived in mounds over an extended period. Sorry, lived in settlements, and these settlements gradually decayed and formed mounds and became elevated locations. The interesting thing on looking at these maps is that there's probably a vast number of features that are not actually archaeological sites that are occupying the same space as features that we recognize are archaeological sites. So how do we solve this problem? Or what do we do to use these historical maps? So we started in many ways by looking at some known features, some famous locations, to see how they were actually being depicted in these maps. So looking at the archaeological site of Harappa, for example, which is in the Punjab region in Pakistan, you can see this is an archaeological site that was known in the 19th century. It was actually documented by various people that visited this location, and by the time it was documented on a Survey of India map in the early part of the 20th century, it was already being referred to as the sites of the ancient cities of Harappa, which you can see here. If you look adjacent to the Gothic script name of the ancient cities of Harappa, you can actually see a sequence of form lines that show the outline of these archaeological mounds, which make up the main city, or the main ancient Bronze Age city of Harappa, which you can see located in the central part of this image. But if you also look further up to the northern part, there are also other features that lie outside of the city of Harappa, the ancient settlement of Harappa. And these are marked in the illustrations in the same way. They have dotted form lines around the outside, and they also have crosses to show that they represent abandoned villages, abandoned settlements. So even very, very close by to a known and very famous archaeological site, the surveyors were also documenting other features in the landscape. If we look today at a satellite image, you can see that what we can see in the early part of the 20th century was the mounds at Harappa and various settlements you can see close by. And that landscape is actually broadly similar, but it's also much more densely occupied. And this is a very, very common characteristic of landscape change, especially as a result of the dramatic population increases in the 20th century and the early 21st century. And if you look closely, you can probably see areas where the mounds actually sit, but many elements of the landscape that were visible in the early part of the 20th century are no longer visible in the satellite imagery, or at least no longer easily visible in the satellite imagery. So knowing this sort of information exists, there's been archaeological work that's been carried out as part of the Two Rains project, but also associated Marie Curie projects. Now, this is the work done by Arnau Garcia while he was based here in Cambridge, where he set out to systematically document a very large area of the southern part of Punjab in Pakistan, and using these historical maps, looking at the different sorts of features that were shown on the historical maps, which you can see on the lower left-hand side. We see the depictions of forts, which are referred to with the name of the fort written after the word Kut. And then you can see a sequence of specific symbols that show the forts themselves. You can also see adjacent to that, there's a ziyarat and other sorts of features that are visible. Adjacent to that, you can see images of abandoned settlements that are shown marked with crosses. You can also see features of other, on the lower left, you can see different sorts of religious structures surrounded by different features as well. And the lower of the four images on the lower left hand side, the one on the right shows the name of a village which includes the word Tibi, which suggests that there's also some sort of mound feature associated with it. Now, when put together systematically, Arnau has been able to ascertain that there was actually potentially many, many thousands of archaeological sites in what was a relatively small area of southern Pakistan. Now, and this is looking at all of the different types of mound features that we can actually identify from the maps. If we compare that data together with what we see from the archaeological settlements, or the known archaeological settlements, we see an abundance of matches between the known surveys and the features in the historical maps. But perhaps inevitably, there's many more features from the historical maps than what is known from the surveys. Now, just to give you an explanation of the type of work that we've also done in Northwest India, we've also done a lot more systematic analysis of these sorts of map features, but we've matched that together with surveys carried out on the ground. Now, this is the work that's been carried out in conjunction with Banaras Hindu University and has resulted in a number of publications. And it was very clear that the surveys in this particular part of Northwest in India had been very good at documenting heritage sites, both known and unknown heritage sites. So our work has been carried out over the past 13 or 14 years, conducting surveys in a variety of different areas. And we've tried to effectively systematically explore the landscape as best we can. And what's interesting to note in the work that we've carried out is that there is actually several instances of very, very famous archaeological sites that were documented in the very early part of the 20th century, but not rediscovered, in inverted commas, by archaeologists until much, much later on. Now, this is the map sheet that shows the location of the ancient city of Rakhigari, which is a very famous archaeological site. And you can see that documented on this map sheet were a number of mounds which correlate with the mounds that are now known of the archaeological site. And so we could see that even at this point in time, if archaeologists had known what to look for, they would have actually already been pointed in the right sort of direction in terms of features that could be documented. So what we've done, in addition to looking at sites like Rakhigari, we've also looked in the areas around Rakhigari. So this is a map showing the location of Rakhigari in the center. The green dots on this illustration show the location of the known archaeological sites before a systematic survey had been undertaken. The more solid dark lines that zigzag across this map delineate the boundaries between different administrative districts. And what you can see actually is that there's two districts on the right-hand side of this map that have been surveyed much more extensively than the areas on the left-hand side of this map. So already you can see that there's been an impact on where surveys have been undertaken and what we actually know about the archaeological evidence. We conducted a survey in 2009, and that survey resulted in a dramatic increase in our knowledge of the distribution of archaeological sites around Rakhigari. And this was a bit of a matchup between looking for archaeological sites using specific methods of village-to-village survey, but also connecting those site locations with what was visible on the historical maps as well. What became very clear was that there was actually important hinterlands of information about archaeological sites that could be understood and reconstructed. And here you can see the location of Rakhigari up in the very top right-hand side. And in the area to the southwest of Rakhigari, you can see a series of archaeological sites that are distributed. It looks like in a broad line, depending on how close you squint your eyes. But it gives you a bit of an idea that there's actually quite rich hinterlands around these urban sites that can be understood. So starting as part of the Two Rains project, we set out to systematically document, again, a very large area with all of these thousands and thousands of map features. And this shows you on the lower right-hand side where the Rakhigari area was, and an area to the north and to the west of Rakhigari, showing the vast regions that are actually documented with the historical maps. So this was work that was done in advance in the lab, using maps and using GIS methods to tag these maps and to understand them. And then once that information was gathered, it was then possible to conduct systematic on-the-ground archaeological surveys, and using a sequence of tools, digital tools that would enable us to document archaeological sites in a specific way, to document them using tools like mobile phones and tablet devices, and to record information about their location and record information about their periods of occupation. And this system that we've developed is very much thanks to the work of Dr. Adam Green, working with Dr. Aftab Alam and Amit Ranjan in the field especially, and a number of other collaborators who have been able to sort of systematically and quickly visit archaeological sites, identify the locations of those sites, and make assessments of the preservation of those sites. So this shows you what we can see using things like Google Earth. We inevitably have to do a lot of interaction and discussion with local populations to find out information about the archaeological sites of interest. We inevitably also encounter all sorts of different stages of preservation of these archaeological sites. Some of them are actually under active cultivation, as you can see on the top left and the top right. Some of these archaeological sites are quite badly damaged, but some of them are actually quite well preserved. And all of that sort of information can be documented. And what you can see on these images is that on the satellite images themselves that are often visible, it's possible to see a mound feature, but actually it's only really possible to get lots of information by assessing these archaeological sites on the ground and actually conducting detailed analysis and assessment. At the tail end of all of this, what we learn is a lot of information about archaeological site distribution. We document hundreds and hundreds of archaeological sites, and they enable us to reconstruct landscapes and landscape change over time. So we can see, for example, where village settlements were distributed before the development of cities in northwestern India. We can look at what happens when urban settlements develop and where settlements were abandoned and settlements were concentrated in certain areas. And it's also possible to look at what happens after a city declines and where populations redistributed themselves into the landscape and the way that those settlement patterns exist. So hopefully you can see that by starting with a tool, a document that was created as part of an imperial mapping project and that has continued on and is actually continuously being updated up to the present time, we actually have the opportunity to look at historical documents that are actually recording ancient settlement landscapes. And that creates an opportunity for us to get a really keen understanding of what the situation of preservation of these sites was around 100 years ago, which is very different to what the situation of preservation is for now. And so therefore we have a method and a mechanism for documenting lost archaeological heritage, but also potentially helping us look for archaeological heritage that is perhaps hidden in plain sight right before our very eyes. So just the last slide I'm going to show you is literally a thank you slide. Inevitably, this work is only possible with the collaboration and cooperation of large numbers of people, whether that be a large group such as what we're speaking, the type of group that we're speaking to now, lots of collaborators that are either working together in different countries, people bringing different knowledge and different technologies, and ultimately also people working together in collaborative teams on the ground. Thank you very much.
Many thanks, Cameron, for this wonderful overview of the Survey of India historic maps and their use, kind of with the different examples that you were giving of the use of these maps. And now, if you have any questions, please type them in the chat box. We're going to have a short presentation now, and then we're going to have a joint Q&A session. So please type in your questions in the chat box for Cameron. And so now we're taking a step back, I want to say, to talk about some kind of, after introducing or giving this amazing overview of the maps that Cameron gave us. So we wanted to look at the actual maps and what are the practices to storing and digitizing them. And that is the subject of our next presentation. Junaid Abdul-Jabbar, he's the MAHSA project database manager at the McDonald Institute, and he's going to talk to us about that. Junaid, if you can unmute yourself and share your screen and start your presentation. Thank you.
Yes, thank you, Azadeh. Let me share my screen. You can see my screen now.
Yes, Junaid.
Okay, thank you. Good morning and good afternoon, everyone, depending on the time zones. So I am Junaid Abdul-Jabbar and working as the database manager for the MAHSA project. In this very short session, we are going to look into the digitization process for the historical maps. We will look into how we can make an effective storage structure for these. We will also look into some of the available archives and repositories for these maps and what is our aim with promoting the open access for these map cities. Starting with what is digitization, it is simply the process of converting information into a digital format. Digital format can be defined as the organization of information in a way that can be processed by computers. So with example of historic maps, these maps can be in the digital format, that is, these can be viewed on a computer or another device with computing capacity, or these can also be in the physical form, for example, printed on a paper. So the digitization process can also be known as imaging or scanning, where these large paper sheets are fed into a scanner and we get the digital file for these maps. So now that we have these paper maps in the these historical maps in the paper format, why do we need to digitize them? Because digitization has a number of benefits, including easier preservation. When these maps are in the paper format, there is a considerable chance of their deteriorating quality over time if these are not handled with care. As we have already seen that several of these map sheets that we are working with have horizontal and vertical folds in them from the time these were not treated as non-digital files during the transportation and preservation. So we can get rid of such deterioration over time when we are dealing with these map sheets in digital format. And it also allows us easier access and sharing of the information. For example, a map in the physical form or a hard copy is only available for access at the physical location of its storage. Whereas if it is digitized, it can be made available online, and many people can access it at the same time. So while we are digitizing these map sheets, there are several considerations that we need to take care so that the digital document produced is of high quality. One of these considerations is the scan resolution. The resolution can be defined as the amount of detail a scanner can capture. So if we look at the image here, we can see that if the scanner, we are doing the scanning in low resolution, the feature is very generalized and there is not enough information to determine what is it. You can see there are very large squares, also known as pixels, and we cannot get a very good idea of whether this is a circle or what sort of feature or shape is represented here. However, if we gradually move towards a higher resolution, we can see the shape of the circle becomes more clear and more discrete. Like we can see in this final image where we can definitely identify that this is a circle and it has a very defined discrete boundary. So let's look into this with an example of from historic maps. as Cameron also mentioned in his talk, that there are several features and legend symbols that are available on these historic maps that help us identify the type of the feature represented. So in a high resolution historic map, the Hatcher Mound can be identified as this feature with a relatively defined boundary and these spikes or hatches over it. And if this same Hatcher Mound is detected or available in a low resolution map, we can see that this image is much more pixelated, and it's not very discrete in terms of its boundary. So a higher resolution historic map can help us to improve our machine learning results, as this is one of the aims of our project, that we are going to run a machine learning algorithm on all of these historic maps so that we can identify the archaeological features. So if we have these historical maps in high resolution, the algorithm can better identify these, because now we can have a higher degree of differentiation between different symbols and available on these maps. For example, symbols for Hatcher mounds, or the form line mounds, or the shaded relief mounds, and other symbols. It is also important to consider that the resolutions for our map sheet is uniform across the data set, because if we are training our algorithm for a different resolution of sample data set and then running our algorithm on a different resolution data set, it can result in variable results. So it is important to ensure that we have uniform resolution across our data set. Now, when we have these digital map files available and we want to make an effective storage structure for these map sheets, we need to understand these series. So Survey of India map sheets are labeled with a number like this. This is present on every map sheet. You can see number 44 and -6, and we need to understand what is represented by this number. So here you can see an image which shows that all the area covered and mapped by Survey of India is divided into grid squares. On the highest level, these grid squares are available in 4 degree by 4 degree squares, and the numbering for these is running from north to south. You can see 1 to 7, 1 in the north and 7 in the south, and then from east to west. After 7, 8 starts from here. And we can also see that the empty areas from the ocean and water bodies are left empty because these are not covered in the map sheets. So taking the example of this grid square over here, that is 44, this can be plotted on the map like this. It is covering the regions from Pakistan and India, and this 44 is coming from first part of the number on this map sheet. And this 4 by 4 degree is further divided into 16 smaller squares, which are numbered with ABC, like 44A, 44B, 44C, 44D, and so on. And you can see that there is a 44N grid square over here, which makes the number as 44N. So this 1 degree to 1 degree grid square is further subdivided into 16 smaller squares, which are numbered as 44N01, 44N02, and so on. So now we finally know that 44N6 is basically this grid square, and we readily know that the area available in this grid scale is mapped and covered in this map sheet. We can use this understanding of our map series to lay the complete structure of naming and folders, so that we are quickly able to identify and relate these map sheets in a GIS system and on our file storage. So using this understanding, we can make an easy to navigate hierarchical structure where the higher level can be the 4 into 4 degree grids like 44. This further subdivide the folder on the basis of 1 degree to 1 degree grids like 44J, 44K, 44N, or other alphabets. And these folders would contain the individual map sheets like 44J01, 44J02, 44J03, and so on for all the folders, which allows it really easy to navigate across our dataset and quickly reach our required file. All of this information can also be coded into the naming structure of these map sheets, which is very important and allows us to have a consistent and logical naming scheme that can help us easy identification and locating of the documents. Here we can see that there are two file names. This is a very large file name, and it contains a lot of information that can help us to understand what sort of file this is. We will ignore some part of it because these are the names that are used by Cambridge University Library, and these include class marks, information about the year and the type of the file. But if we focus on this part over here, we can see that it includes the same information from our understanding of the map series like 44 and 03, 44 and 07, so that we can quickly identify our required map sheet. Now, as any other data set, this historical maps data set is also of immense importance, and we need to take a backup of the data. So data backup is the practice of copying data from a primary location to a secondary location, and it allows us to protect in case of disaster, any sort of primary storage failure or technology malfunction, so that none of the effort that is done in the digitization and georeferencing of the historical maps is lost in any case. There are different storage options that are available to take backup and store these map sheets. These can be different in different institutions or what is available to you. But we all know about Google Drive. Then there are SharePoint sites, and then there is also my OneDrive storage. So in Cambridge, we also have the provision of institutional file store. There is research data storage, and then there is the research cold store. So all of these storage options provide you different sort of benefits. For example, the research cold store provides you with long-term backup and archiving for non-active data sets. So depending on your requirement, we can choose one of the options. And we can also benefit from the recovery functionality that these storage platforms provide. For example, to recover our version of data from 1 day back or 2 day back. So, but it is very important to take the backup of these data sets. So during our work with historic maps, it is very important to consider the copyrights while we are porting these maps in our research work. And we need to know, we need to duly mention where required the copyrights. For example, on all the map sheets that are available from the university library, we can see this red stamp that includes the information about university, about Cambridge University Library and the date, month, and year. So we need to mention and refer to the university library or British Library from where the map sheet is available. And we have found the several of archives available for these maps, where one of the largest collection is available with British Library. There are also several maps available with the University Library. A relatively smaller set of these maps is available with Bodleian Library at Oxford, and then also the National Library of Scotland. And then we also find some copies of these maps in repositories like Zenodo, where some of the low resolution scans for these maps are available. Here, I would like to mention that the team has prepared a very comprehensive document and guide to understand the naming structure and information about these repositories. And it would be circulated with, and Azadeh will circulate it with all the participants after the workshop, so that you can see the details. It also contains the links to the different repositories. So our aim with working with all of these historic maps and generating the archaeological data set, identifying mounds through machine learning, we also are aiming to promote the open access for these map series. For example, in our ARCHIS database, we are structuring it such that all the machine learning identified sites are related to the respective historical map records in the database. These records would contain the information about the map attributes and also have the external reference information that will be pointing to the respective libraries, along with having a spatial footprint so that we are able to identify from a map that we are interested in this area and see that the number of the map sheet that is covering that particular area. And we believe that this structure of the database would largely enhance the discoverability and access to these historic maps to promote the open access. Thank you. That is all from my side, and you are welcome to ask any questions. I will stop the screen share.
Thanks, Junaid. Thanks for the great presentation. And now we have 10 minutes time for question and answers to both Cameron and Junaid's presentation. We already have, if you can type in your question in the chat box, we already have a few that I'm going to ask people either to unmute themselves to read the question, or I can read the question. The first question is to Cameron from Amr Khan. Amr, do you want to unmute yourself and ask your question?
Hi, Cameron. Thanks for the talk on the maps and some of those techniques used to identify mounds relative to known sites already. And I thought that was really useful, where you had existing sites with the same sort of symbology that covered a known site being used in a nearby area, which hadn't, at that stage at least, been identified as being part of the site. And I was wondering if the sites being located for different periods were represented differently within the maps, so non-Harappan period sites as well. So if you could talk about some of the diversity of historic places discovered through this approach. Just hoping to hear more about that.
Thank you, Amr. That's a good question. I mean, so one of the sites that I showed in one of the images was a site called Agroha, which was is actually a protected mound that was excavated originally in the 1930s. And it's a historic period site that was occupied throughout the early historic and up into the medieval period. And that's actually quite close to the city of Hisar in the state of Haryana in India. And that basically, it appears that in the same way as these other sites, but because it's so large, it has contours. So it actually appears as sort of a topographic feature. But what's interesting is that the protected part of the site is the bit that's actually the most obvious. And then if you look at the historical maps as well, you can see that there's actually other mounded areas, including a large area with a fortification wall around the outside, which is both outside the protected area of the site, but it's also not visible easily on the modern map. So so you can actually see it once you know what's shown on the historical map. You can then look on the modern map and work out where the walled area is. So these maps document mounds of all sorts of different periods, and they definitely document mounds that are post Indus civilization in the area that we're working. Which is really quite interesting. And we've demonstrated that also with the surveys on the ground. When you go and look at them, that in actual fact, the vast majority of sites that we visit are actually dating to the historical periods. They're either early historical or medieval in date. And also, you can also, what we see is many of the mounds that are visible on the maps are now occupied by modern villages as well. So they become as part of this continual occupation of the landscape.
Thanks very much, Cameron and Amr. And next question is from Muzaffar Ahmad, and I think he wrote his question before Junaid was presenting about the location and where you can find these repositories of Survey of India maps. And as Junaid said, we're going to also share a document with where you can find these repositories in the UK mainly. But if a part of your question is not answered, please you can unmute and ask your question if there is anything else you want us to answer.
Thank you. Can you hear me?
Yes.
Yeah, when I was searching for these databases, two things I find missing. Maybe you have discussed here in this lecture. One is the aerial photography, aerial mapping of India in 1944. And the other thing is the pre-triangulation survey revenue maps, which shows the sites on a much larger scale than 1 inch, 1 mile. If you have covered it, I will listen to it later on YouTube, or if not, you can guide me. Thank you.
I mean, I can provide some answers to that. So the aerial photographs are actually often still not released for general use, but there are archives that exist, to my knowledge, both in India and Pakistan, and also in the UK, of these historical photographs that were taken. But they're not widely available, and that actually requires quite a lot of work to find them because they haven't necessarily been catalogued systematically in the library collections. Similarly, a lot of the topographic sheets from the revenue surveys are also not easily available. And I think a lot of them are sitting in the archives of the Survey of India and the Survey of Pakistan as well. And I think because they are a part of what's in effect now still a part of military control, they're actually restricted access. So they're actually quite difficult to get access to. What we're making use of mostly is what's available in public libraries. And that material has been accessible for a long period of time. But we do know that the collections that are in the libraries are not necessarily complete. So each of the archives is similar, but not identical. And that's an interesting factor.
Thanks very much, Cameron. We have time to answer another question, and then we can answer the rest in the chat. So if you can ask your questions in the chat, we can continue to answer them. So the next one is from Shikha Rai. Would you like to unmute yourself and ask your question?
Okay, sir, I have a question. Like, if we are getting these sites on historical maps, do you feel that it will go through multiple maps just to cross-referencing? How much it is helpful to rectify that error? And the second question is about hydrological map. Like you were showing that site of Alamgirpur, there is an error of 11 kilometers. So how much we can rely on such maps when we are doing this hydrological analysis depending upon such historical maps?
So the point about Alamgirpur was actually that the location of the site in the gazetteer was incorrect, but the location was correct on the map. So in actual fact, the maps are more accurate and more reliable than many of the published lists of archaeological site locations. Now, what's most useful with a place like Alamgirpur, for example, is that if you use the gazetteer location, it suggests that the site is located 5 kilometers away from the river. But if you look at the historical map and actually visit the site on the ground, you can see it's actually located on the edge of a river's floodplain. So it actually the maps are giving us an opportunity to get many layers of information about hydrology and local landforms and all sorts of other things. You asked about cross-checking. So I think this is where many people have attempted to find or visit archaeological sites that are listed in these gazetteers, and they've often had difficulty because the locations are incorrect. And the maps, because of the way that they were produced and issued, they were recorded as, the surveys were undertaken, then the maps were reproduced, and then often at a later date, the areas were resurveyed again. So you can actually also look at change over time in the last 100 years as a way of getting understanding of the impact of threats from urban expansion, for example, or river shift if a river moves and the floodplain changes. So there has been an example of the documentation of a city called Diyai Khan in Pakistan that was surveyed in 1909. And in 1912, there was a big flood of the Indus River and the city was destroyed. And that is actually documented. That process is documented on the historical map. So you can see where the river moved and changed. It's very interesting.
Thanks very much. We have a few more questions, but we don't have time to answer them live here. So I'm going to ask both Cameron and Junaid. There's one from Alexander to Cameron and one from Kidu to Junaid. And I see Sabine's hand is up. I message you, Sabine, if you can kindly ask your question in the chat box, we will answer your question there. Thank you. And now we can move to our next presentation. Next one is a joint presentation. It's given by two of our RAs at the MAHSA project, Jack Tomani and Afifa Khan, and they're going to talk about more technical sides of what we do and about the basics of georeferencing and how at MAHSA we develop a methodology for the georeferencing of these historical maps. Jack, to you, if you can unmute yourself and then share your screen.
Hey, can you see my screen?
Yes, yes, thanks, Jack.
Brilliant. Thanks, Azadeh, and hello, everyone. So, as Azadeh said, my name's Jack Tomney, and I'm a research assistant on the MAHSA project. And together with, if you can't, sorry, there we go. We're going to be talking about the next steps after digitizing the paper map, which is georeferencing. And more specifically, we're going to talk about our methodology for the systematic georeferencing of maps. So it's great to see so many people on the call, but I know that the audience has a wide range of experience using geographic data. So to put our methodology into context and for it to make sense, I will first be going through the basics of georeferencing. So I'll be explaining what it is, what it's used for, kind of technically, how it works, and some of the key terminology to do with that. Then I will pass over to Afifa, who will take over and talk more specifically about how we are referencing the Survey of India maps in the MAHSA project and how we are manually identifying archaeological features from these maps, and then the next steps after this in the process. So it's been said a few times in the presentation, but first I'll explain what actually is georeferencing before talking more in depth about this. So a succinct definition of georeferencing is the process of assigning locations to geographical objects within a certain frame of reference. Now, I've taken that from a paper by Hakaloa et al. In 2014. And I like it because it's a very short definition of this. But in other words, it means that georeferencing is the process of taking digital images, such as paper maps or remotely sensed data taken from planes or satellites, or really any image that has a geographical aspect to it, and associating it within a reference system so that a user can determine where every point and therefore every geographical object on that image is actually located on Earth. So now I've defined georeferencing, I thought I'd just show a few interesting maps that have been georeferenced, not from this project, just some nice ones, just to get an idea of what it is. So this is an 1892 map from Antwerp in Belgium, and as you can see, it's quite a detailed map. It has some nice pictorial pictures of buildings. So after it's georeferenced, we can see that the map then lines up against where it actually is on the Earth on Google Maps behind it. So we can now see exactly where these buildings are. This can also be done over a larger scale. And this is a 1919 map of Madeira that I've made a GIF on. So you can see that it's been georeferenced to the Google Maps behind it. And it comes on and goes off. And you can see that the map has loads of really interesting topographical features. And once georeferenced, you can find where these topographical features that are shown in this 1919 map are actually on the Earth. And finally, you can georeference for even larger areas. So this is a composite map of South America from 1718, which I really like, and it's been georeferenced over a Google satellite image of South America. So I think it's really interesting. There's lots of areas missing from the map that the cartographer didn't know what was there. And you can see it's been bent out of shape to fit its actual location. So I'm now going to talk about the technical aspects of how to georeference an image and some of the terminology that's important to know and to understand when designing a methodology for doing this. Because in some cases, although it may look like it, it's not as simple as just placing the map on top of the satellite image. There's actually quite a lot of technical work that goes on. So amongst others, there are 4 main steps that need to be done and decisions that need to be made during georeferencing. And I'll expand on each of these in the following sections. So first is about reference systems. So the images that we want to georeference, such as the paper maps, have historically been created and drawn in many different coordinate reference systems and to many different accuracies. And these need to be georeferenced into a known coordinate reference system so that they can be viewed accurately on a computer. As when the historic maps are initially digitized, as Junaid talked about, they will only be associated to the computer with the digital image's internal reference system rather than the coordinate reference system that they were drawn in. So to do this, the digital image will need to be transformed from their internal image reference system to a coordinate reference system. And this means that they will need to be stretched, scaled, bent, curved in specific ways. And so often they will also need to be resampled so that the locations on the image actually fit those locations on the Earth. So we need to decide on how much we want the image to be transformed and how we want it to be resampled. And in order for the computer, for the GIS to know how to transform the image, ground control points need to be selected by a user. So all of the process that I talked about is commonly done in a GIS, such as ArcGIS, QGIS, NV. There are some kind of online GISs that can also be done. I know that there's crowdsourced georeferencing of images that can be done on specific online GISs as well. Okay, so first I'm going to talk about reference systems in a bit more detail. So when I talk about reference systems in georeferencing, I am referring to 2 different reference systems. And this is first the internal reference system of the digital image that has been scanned. And second, it is the coordinate reference system, which is what a historic map had originally been drawn into, but also what we want to project the digital image to. So to go into a bit more information about these 2 reference systems. First, the image reference system. So as we know from Junaid's presentation, digital images, when they're scanned in, they're made up of pixels, and the higher the resolution, the more pixels there are that show that image. So the digital images are often made up of millions and millions of pixels. This image on the right-hand side represents how a digital image looks when it's very, very zoomed in. So very, very, very zoomed in. So that each individual pixel that makes up this image, which is the colored squares, can be seen. The pixels have numeric data associated with them, which can refer to a characteristic. And in the case of historic maps, the data in the pixel refers to the color that pixel makes up on the picture of the historic map. So when we open these images and data sets, such as these in a GIS, we refer to them as raster data sets. And a raster data set can hold 4 locational characteristics in order to place the image within a GIS. And this is, it can hold a coordinate system. It can hold a reference coordinate. So this is almost like the starting coordinate of the image, which is often in the top left of the raster. It will hold the cell size, so the pixel size of the image, and a count of rows and columns. So these properties help the image to be correctly located. However, when first opened in a GIS, the digitized image raster won't have any of these properties related to any location on Earth. Instead, it will have an internal image reference system, which is based on the rows and columns of the pixels. For example, if I can draw on this, the top pixel in top left-hand corner will usually be pixel 0, 0 as the image reference systems will start in 0. The one beneath it will be 1, 0, and the one to the right will be 0, 1. Pen off. Okay, so in a similar way to how the image knows what pixels are where based on this numeric system, we also have reference systems on Earth, so we can pinpoint locations using a system of numbers. These are called coordinate reference systems. So there are many different coordinate reference systems, and to explain why, very briefly, the shape of the Earth is actually is a geoid. So without going into too much detail, a geoid is like an ellipsoid, but it's not so smooth. So some bits are bumpier than other bits. This image is obviously exaggerated representation of that. So it's obviously too complex to for a geoid to be used as a reference for measurement. So what is done to make a consistent map is a reference ellipsoid is used as an approximation of the surface of the Earth. And this image shows that. So the red perfect circle is the reference ellipsoid, and underneath it, the black kind of bumpy image is the geoid of the Earth. So this approximates the locations on the Earth. So once we have this reference ellipsoid, we then have a 3D shape for which to draw longitude and latitude lines, which create a coordinate reference system. So this coordinate reference system works in the same way as the image reference system, in the fact that each location on the surface of Earth, just as the pixels in the image, have a set of numbers which can be used as a reference point. So the reason there's many coordinate reference system is the fact that the reference ellipsoid doesn't fit perfectly, as you can see from the middle image, on everywhere on Earth. So there are many ellipsoids, with some perfectly fitting some locations and some perfectly fitting others. So some are better for local measurements, some are better for global measurements. So in this three-dimensional coordinate system is called a geographic coordinate system. However, most maps are viewed in 2D, especially historically. And we need to flatten that geographic coordinate system into 2 dimensions. So when we do that, this is called a projected coordinate system. Obviously, projecting a 3D image onto a 2D surface doesn't always work perfectly. For example, if you were to take the skin off an orange and try and flatten it, some parts of that skin would be bent in different ways. It wouldn't be evenly flattened. So there are therefore many different ways of mathematically projecting this geographic coordinate system into a projected coordinate system. An example of 2 different ways of projecting the same geographic coordinate system is shown here, with the image on the right giving the same amount of area to each line of latitude, which elongates the poles, whereas the image on the left is a projection that preserves the actual relative areas of the Earth. So the poles are a lot smaller. So when georeferencing, it's likely that the historic map will be drawn into a coordinate reference system. Therefore, we need to choose a sensible coordinate reference system to digitize this image into, which is preferably the same one that the historic map has been drawn into. And we do that so the map isn't completely distorted, and so that if we're doing a series of maps, which we are, the map series can consistently fit on the map. It's important to choose a CRS based on the purpose of the map and the project. And just to give an example, there's almost 3,000 different coordinate reference systems in QGIS, so a lot to choose from. So in essence, what we're doing in georeferencing is we're translating the image's internal reference system into a coordinate reference system. As shown in this rudimentary diagram, you can see on the left, the input units are pixels, which is the image. And once georeferenced, you can see that that image is now in map units. So that will be measured in degrees, meters, or whatever the coordinate reference system you're using is measured in. In actuality, it doesn't happen exactly like this, and I will explain a bit later, and that's because images have to be transformed to fit the coordinate reference system. But this is a useful interpretation of how to understand what georeferencing is doing. So once we know what coordinate reference system we want to project the raster into, we have to tell the computer where the raster image should be within this coordinate reference system. And to do this, ground control points have to be selected by the user. So ground control points are locations that are visible on both the historic raster image, but also on the image that has already been georeferenced to the chosen coordinate system. So this could be a satellite image or Google Maps. So what can be used as a ground control point? Pretty much anything that is visible on both the historic map and on a georeferenced image that hasn't moved that we can identify can be used as a ground control point. FIFA will go through a bit later what we've been using in the Survey of India maps, but just in his example, his 2 points from a map, I think it's in Amsterdam, where you can see that there is a junction on the road in the red on the left, and you can still see that junction on today's map in the image on the right. And the purple image shows the junction in a canal in the historic map that you can still see in the map on the right. So what you do is you select these ground control points on both of the maps, and when they're selected, a control point pair is made. And this defines a relationship between the coordinates of the internal reference system and the coordinate reference system of where those pixels actually are on Earth. So general rule is that the more ground control points that are selected and the more spread out they are throughout the historic map, then the more accurate the georeferencing will be. Okay, so now we know which coordinate reference system we want our map to be in, and what ground control points are and where we're going to place them and how many we need. So now we need to decide on how much we're going to allow the historic map to be transformed to fit the coordinate reference system. So this is what a transformation type is. And it's essentially an algorithm that takes the locational data of the ground control points and translates the entire digitized image from its internal reference system to the coordinate reference system. There are two types of transformation types, but I'm just going to go through one. So there's global and local, and I'll just go through global. And the most common of the global transformation algorithms is the polynomial transformations, which you can see in the image on the left of the screen there. So these are least squared algorithms that create one formula based on all the ground control points to apply to the digital image. So as it uses all the ground control points, it may mean that there's a slight shift to where the ground control points end up from where they have been designated to, but this is so that the map is transformed to best fit all of the ground control points and not distort the image specifically towards any single point. So as you can see from the diagram, the higher the polynomial order is, the more movement that is allowed by the algorithm. So the first order polynomial will allow the image to be shifted, scaled, and rotated, but it can't be bent or curved. The second order polynomial allows some bending and curving of the digital image, whereas the third polynomial allows even more bending and curving. So you can see it actually looks quite wavy on this diagram. So it's really important to pick the best transformation type for the image, as too much movement can lead to the image being distorted towards specific GCPs, where too little movement may end up with the image being too rigid and not fitting the correct locations. So finally, the last setting, the last technical detail that we need to be considered is which resampling method to use. So after the transformation is applied to the input raster image, we know it's often bent, squashed, and distorted, as I just showed. However, in a GIS and within a specific coordinate reference system, raster cells, or as I showed before, pixels, need to be the same size as each other and square. But due to the transformation, the pixels of the input image are often not even sizes and they're not square. So what happens is, and this sounds a bit complicated to explain, but I'll show a diagram in a second. So what happens is a new empty matrix of cells that look like the pixel image I showed you earlier is created based on the coordinate reference system, transformation, and on the map coordinates given by the ground control points. And then values are then assigned into each of these cells of this new matrix from the original transformed image. So this is resampling, and there's several techniques used to assign the value from the transformed image into the new empty cells. To explain that a bit better, here's a picture of the transformed historic image after we have applied the transformation to it. So as you can see, there's 9 pixels here. So these are the squares which have been warped and bent, and the points indicate the center of these pixels. So what's happened is, for the georeferenced map to be correctly made, the GIS puts a new grid of cells over that location of where the transformed image has been, indicated by these red squares. So you can see that the cells are now even and they are square, but they don't match up with the original pixels. The red cross is, by the way, is the center point of the new grid of cells. So, the resampling is used to assign values from the image, from the original image to the new cells. So here, for example, this is the nearest neighbor method, where the value of the center of the input pixels closest to that of the new output cells is used as a value for the output cell. So this preserves the value of the cell, which in the case of ours would be preserving the color of the historic map, but it does mean that sometimes 2 cells next to each other will have the same value. So for example, if I just put the pen on, we can see that this cell here and this cell here have both taken the value from this original cell here because they are both closest to it. So these will both end up being the same color. We have a couple of, the other resampling technique I'll explain is the cubic method, which does the same thing, but what it does is it takes the value from the 4 closest input cells to the output cell and takes a weighted average of this. So this makes the image look smoother once it's been georeferenced, but it actually doesn't keep the original colors of the image. So for a historic map, that is something that we wouldn't want to do. So a real life example of this from some of our historic georeference maps is, and this is the nearest neighbor method. This is a very, very zoomed in portion of an ungeoreferenced map on the left and a georeferenced map on the right. So if you look closely at the A in this image, you can see that there is a row of 3 pixels, which I highlight here, that are slightly lighter than the rest. So 1, 2, 3. So before the georeferencing, there is only 1 row of these, but after georeferencing, they look like they have widened slightly. But what actually happened is there's now 2 rows of pixels. And due to the transformation in the resampling method, and resampling technique that has been used, the 2 rows have taken the same color from the original 1 row. So I've gone through some of the key technical aspects and terminology of georeferencing, and therefore the steps that need to be taken when designing a methodology for georeferencing, and also how different technical decisions can affect the output of the georeference map. So here are some of the questions that we asked ourselves when deciding how to georeference our maps and what our methodology would be. So first, what coordinate reference system we want the map georeference to? Do we want global or do we want local accuracy? Ground control points, what points are present on our maps that can be georeferenced? How many ground points, control points do we think is enough? Transformation type, how much movement do we want to allow the image to have? What type of transformation is appropriate for our maps? And finally, resampling. Will the image need to be resampled? Almost definitely. And if so, what is the best way to do this? Do we want to keep the true value, the true color of the pixels? So now I've gone through some of these technical details, I'll pass over to Afifa, who will talk specifically about georeferencing in the MAHSA project, why we're doing this and what our methodology is for this. I'll stop sharing my screen. And over to you, Afifa.
Sorry, I forgot to unmute myself again. Is that showing now?
Yes, thanks, Afifa.
Okay, thank you. Hello, I'm Afifa Khan. I'm one of the other research assistants at MAHSA, and I'll be talking about basically what Jack has been talking about and how we use it in our project, and also the kind of features that we're interested on the maps and the outcomes we hope to get from them. So there'll be a little bit of repetition maybe with some of Cameron's presentation, but if you missed it or if you liked it as much as I did, then this is your chance to get it again. So we are going to be georeferencing survey of India maps from the early 19th century to, from the late 19th century to the early 20th century, but focusing initially on kind of the post-1906 period to before the 1940 period, because we found that that series of maps were more standardized, were a bit more accurate, and so can provide a better comparison, and also have also been accurately surveyed to a certain level as well. Many of the maps that we've gotten, we've sourced from libraries such as the British Library and Cambridge University Library, but these are all repositories from the UK specifically. We know there are some repositories outside of the UK, and hopefully we'll be tracking those down in due time as well. And as Cameron went over, these maps also, we're using them because they covered an area before rapid urbanization and agricultural activity took over South Asia. And so they got a point where you could find these very interesting features before maybe they were covered with farmlands, or before they might have been destroyed through other processes. So not only do these allow us to track changes in archaeology and in the environment in South Asia, but they can also provide ways of detecting potential archaeology that we have not yet maybe ground truth or found, or maybe archaeology that's been found previously but needs to be refound now. These maps were of quite high quality and precisely made, but the coordinate reference system is a little bit outdated, so we need to adjust our methods a little bit. So you can see here, this is a bit of land in Punjab that's shared by both Pakistan and India. And this is the Google satellite image, and this is the Survey of India map. And what we hope to get is this image by the end. So we want to go from this to this to this. And as you can see, the shape of the Survey of India map changes a little bit once it's been georeferenced, and I'll go over why that happens. Over here, you can also see that once we've georeferenced the map, it matches the satellite image very nicely. And one way you can tell this is this main road here, which follows all the way through. But this is also very useful for us because we can zoom in and out between the layers and see how the features on the maps kind of overlay and have changed between the map and the Google satellite image. So these are the settings that Jack was talking about, and the settings we use specifically. I won't go step by step in what we do to georeference. We use QGIS. So that means we go to the top tab and go to the raster and go to the georeferencer tab. What's more important is that you understand why we use these settings. So for the transformation type, you can see here it's polynomial 2, because it allows for some amount of bending and shifting without distorting the map completely. And that way we can preserve some of the distances between the map and the Google satellite image. We use the resampling method, nearest neighbor, to preserve the colors of the map, which is important because different colored features, so roads and canals, they can tell us different things. The target's SRS or CRS is WGS84, which is a very global standard of coordinate reference systems that helps us reference these maps over a large area, such as South Asia. You can sometimes get very regional and specific CRSs in covering South Asia, but that would mean that you'd have to use multiple. So we found it more useful to use WGS84. Now, commonly, a lot of people, when georeferencing historic maps, will use the corners of the maps. You can see over here that the coordinates are in degrees minutes, and we'd have to convert them into decimal degrees over here. But there are a few issues with doing this for our maps. See here, you get the corners. It's a quick way of doing it. However, because the maps are have aged over time and worn over time, the creases and folds can cause a bit of a warping. So if you take the example of the orange that Jack talked about, if you were to place a smooth piece of paper over that orange, it would match quite nicely. However, if you were to crumple it and then put it over the orange, which is our globe, you'll find that some of the distances have changed and you can't really accurately georeference from that. Another problem with georeferencing from the corners is that the coordinate reference system used by the Survey of India at that point is now outdated. And so we have to use an updated way of georeferencing to kind of make up for that. So we have decided to georeference using the features instead. So these are features that match within the maps, but also within the Google satellite imagery. So this can be major infrastructure, so canals and roads and where they intersect. You can see over here that 2 roads have intersected and this is a bridge over a canal. So a lot of these major pieces of infrastructure match within the maps and within the Google satellite imagery as well. And another example here is of a railroad and a main road, a railway and a main road crossing together. However, in some areas, such as rural areas and deserts, you don't always get a lot of this main infrastructure, or it might have shifted majorly, or sometimes you'll have places where the river has shifted and completely changed the landscape. So we have to be a little bit creative with the kinds of features we've used. In some cases, that means using grave sites, such as this feature here, or using forts, or maybe religious buildings and things like that. This doesn't create the most accurate georeferencing, but in some cases it's all we can really go by. And in any case, in a lot of these places, you might not get the kind of archaeological features that we're interested in looking at anyway. And that's especially true for places like the mountainous regions, where maybe you'll get some forts, but by and large, the kind of features that we want to be detecting aren't really in those regions. And in cases like mountainous regions, you can sometimes use topographical features. So places where certain mountains join up, you can use GCP points. And also you'll find that wells are the same in the historic maps and in the current Google satellite imagery as well. So those can provide some interesting places for GCPs. And a basic rule for georeferencing is that the more GCPs you can place, and the more evenly they're spread throughout the map, the more accurate the georeferencing will be. So as you can see here, we've tried not to have too many GCPs in any one square or in any one area. This is just an image to show the kind of progress we've made already with georeferencing. So the purple squares are the maps that we've georeferenced with the MAHSA project, and the orange ones are the ones that have been done through previous projects. The yellow ones are the ones that we hope to do quite soon into the future. And this is just to show that once it's a map series has been georeferenced, this area is Punjab. So you can see Lahore here and Amritsar here. You can see that these maps line up really nicely together. You have to ignore the borders and imagine the maps as this kind of detailed area here. And as you can see this main road running through the maps here. It shows that it's been georeferenced to a high degree. So there are lots of features on the maps, and some of them Cameron's mentioned already. And you can see there's things like temples and shrines, and these don't always tell you what religion they belong to. So they could be Hindu, they could be Sikh gurdwaras. The only ones that are differentiated are the mosques, which are commonly this symbol here. Gravesites can be kind of indicated with two kinds of symbols. You have this symbol here, which sometimes you get in some of the later maps. More commonly, you'll get these mound symbols. You also have the fort symbol, which you can find throughout the region, but also the kinds of features that are of interest to us are things like wells and ponds. So these are the wells and these are the ponds, and sometimes they can be confused with mounds if they're dried up ponds, because then you just get these lines, these solid lines here, but in any case, they're of interest to us as well. So this is the example of the fort at Kot Diji. So you can see that this, even though this is a very squared symbol, it doesn't always reflect the shape and the size of the fort on the ground. However, we will be more concerned with these mounds that Cameron had talked about, and I won't talk about it in too much detail, but as he said, sometimes you do find that these mounds aren't always archaeological features, and you normally find that with these shaded and stippled mounds here, which sometimes can be river embankments or sand dunes. And the more kind of archaeologically interesting mounds can sometimes be these discontinuous form line mounds, or the Hashid mounds here, which you can see have the crosses indicating an abandoned settlement, or sometimes a temple here.
I'm sorry, Afifa, to cut you. I just tell you that you have 2 minutes. If that's okay.
It's okay. I can
Thanks,
speak through this. Yeah.
So
this is the example of Rakhigari. I liked it so much I used it in my slideshow as well, but you can also see that's the modern satellite image, and it overlaps quite nicely. You can see the archaeological sites here, and then you have the modern town over here. So after the sites have been identified, and this is mainly the mounds I'm talking about, we've created polygons over the mounds, and then this data will be sent to our collaborators, Hector and Ivan, who will be putting it through machine learning processes so that we don't have to manually identify all of these sites. We hope to maybe rapidly speed up the process, but Ivan will hopefully be talking about that later anyway, so I won't go into it in a great amount of detail. But these maps are more than just mounds, and there's a lot of information on them that we're interested in. So in the margins, you'll find all kinds of interesting metadata that we will also be collecting. That includes the survey dates, which will tell you if a map has been recreated using an older map, or whether it's been completely resurveyed. So in the case study of Dera Ghazi Khan, they showed significant landscape change because of the flooding. Other things that we're interested in are the Surveyor General, because then you can track which maps have been created by underneath the same person or with potentially the same team. Also, the legends will tell you the kinds of different features to look out on the map, and also the different kinds of terrain. So this is just to show you, this is the region that the districts that the map will be covering. The indexes will show you what the adjoining maps are. And this is the coordinates of the map in degrees minutes, the legend, the name of the Surveyor General, and also the date that the map was published, not to be mixed up with the survey dates, which are normally found on the top of the map. So we hope to, at the end of this process, get as complete a series of 1 inch, 1 mile maps covering our project area, which is Pakistan and Northern India for now. And hopefully potentially with multiple additions to kind of track that landscape change. We hope to georeference these maps to a high degree of accuracy so that we can accurately detect the archaeological features on the ground, and also create metadata from these maps based on the information I've just shown, the publication dates, the locations, the Surveyor General, etc. And then we also, more importantly, want to locate the mounds and potential archaeological sites, and also the heritage sites using the remote sensing and machine learning methods. So if you want to follow our work, you can go to our website or our Instagram site, or follow us on Twitter as well. Thank you.
Many thanks, Afifa, and thank you both to you and Jack for this wonderful presentation and overview of georeferencing of these maps in general, but methodology that the MAHSA project is using and on how to georeference survey of India maps. I don't see any questions yet in the chat box. If you have any questions, do you have any question about these, about the georeferencing of maps and also the specific MAHSA methodology? I might ask you just to raise your hand and ask your question, just to give us enough time after 2 hours to have a 10 minutes break to move and have a coffee. But if you have any questions, please raise your hand to Afifa and Jack. I think it was very well and clearly presented. Thank you both, Afifa and Jack. But if you having any question, just type them in the chat box, and then both Afifa and Jack will be happy to answer your questions. And now we can take a 10-minute break just to move a bit and have a tea or coffee, and come back. Please come back at 11:10 in 10 minutes, please. But thank you again, both Afifa and Jack, for your wonderful and very clear presentation. And I see you back. I'm going to pause the recording now, and I will see you back in 10 minutes. Welcome back all. It's 11:10, so we can start back and the workshop and the remaining 2 sessions that we're going to have after the break now. Just to quickly mention that in the chat box, I've added our both projects, MAHSA and MAEASAM's social media account. So if you can please follow us and mention us if you are sharing any information about this workshop, and you can follow us to stay tuned about our events, work, progress, etc. So let's move on to our next presentation. We have our next speakers on, Ed and Bernier here. Ed Burnett is from the MacDonald Institute for the MAEASAM's project, and also from the MAEASAM project, we have Bernier Vandermeer from the University of the Witwatersrand. They will talk to us today about the historical maps in Africa. So if I can ask you, I think Ed, you will start first. So if I can ask you to unmute yourself, and you should be able to share your screen as well.
It's not letting me.
We can't hear you, Ed.
Can you hear me now? Yes.
Still no.
Oh.
I can hear you, Ed.
Okay.
Yeah,
I just made you a co-host, so you should be able to share your screen now, but we still cannot hear you.
I can hear. Oh.
Yes, we can see your screen.
Okay.
But still, we cannot hear you.
We can hear.
We can.
Yes.
Yeah. Yes.
Oh, Nadia is saying that she can hear you. Maybe it's me. Yes, sorry.
Sorry. This wouldn't be a workshop without some sort of technical error. Okay, so if everyone can hear me and see
I'm
now.
very sorry, Ed. Yes, it was my problem. Go ahead. Sorry.
Okay, so yeah, I'm going to talk a little bit about some different ways that we've been doing things at MAEASaM, and also about a bit more detail about certain parts, and particularly going into, as you can see here, some things to do with verifying features. So far we've heard about how you might digitize a historical map, and then how you might georeference the historical map. I'm going to go over these a little bit as a brief refresher as well. But then I'm going to talk about some problems with verification as well, and some issues that I've encountered while working in Sudan. And then after that, Rainier is going to go into a lot more detail, because yeah, he's had some particular success working in Southern Africa. So we've already kind of gone through this a little bit, but just again as a brief refresher, when you see a historical map, what are the useful parts, I guess, is the first question. I mean, in Africa, we have a lot more disparate map series than the ones that MAHSA are working on, because, I mean, there are 8 countries that our project is studying as well, and obviously there are more than that as well. And how they've been mapped has been very, very different in different areas. So, for instance, most of the parts that were colonized by the French, the maps are in French and they're in different places. There are all kinds of problems like that. Also, things aren't necessarily in as much detail. We have problems with scale. So here you can see that this map is on a fairly large scale, which means it contains not very much detail compared to the maps that MAHSA are working with. Really, anything larger than this is really useful, but 1 to 250,000 you can just about work with. So, you know, when you see a map series, there's a lot more investigation, I would say, that has to be done for the maps that we're working with as to whether or not it will end up being useful, which is why I'm suggesting all of these bits of information you can find on the sheets. So obviously, yeah, we have the scale, we have the sheet number, and also name sometimes, which obviously will follow a different system to the one which Junaid explained earlier for the maps in India, that these tend to be different even within the same country. You will have multiple versions that have different ways of referencing sheets, which is very annoying. And then you have a key. This is part of the key on the bottom left. Again, some maps will not include any information that is useful at all, really, but some will contain a lot. So you can see, for instance, the antiquities are listed here in the same kind of Gothic font that you get here, if you can see my cursor. and you know, deserted villages are fairly useful because this map series is from the 1930s mostly. So if they were deserted almost 100 years ago, they're definitely interesting archaeologically. You can also see things like Qubas, Islamic dome tombs in this particular series, and a lot of other information as well in different ones. Then, as I've just mentioned, the year, which can tell you a lot about how, I mean, in one sense, older maps tend to be better in some cases because things that they include as current features might now be interesting, right? Whereas a more recent map, things that are current features are probably not as interesting archaeologically, although obviously that depends a lot on different circumstances. But the older ones are much less likely to be accurate. And something else that is often very useful to look at on these maps is little notes, right? So this one, for instance, lets you know that there are earlier surveys, which are what have been used to produce this map in the 30s, and things like boundaries have been updated, but in terms of the actual locations of things, they're based on these earlier surveys, which were also not very good. So there are a lot of inaccuracies in this particular map series as well, which is something that I've had to kind of deal with. And one thing you'll notice is missing here is any reference of a CRS, a coordinate reference system, or a spatial reference system, which is also a problem in of itself. These maps don't tell you how they've been made, really, at least as far as I've known in this particular series. In other ones, they will, and that's very useful for the georeferencing process, but in this one, they don't, and you have to kind of work with that, basically. Again, Gina, you sort of discussed where to find historical maps. One almost advantage of the disparate nature, I guess, of the mapping that we're working with in Africa is that there's a lot of places you can find them, and that includes online. So, for instance, the Peru Castaneda Library Map Collection at the University of Texas is very, very useful. The Library of Congress has the entire 1 to 250,000 series of Sudan from the 1900s, the early 1900s, available online, and I could just download all of them, which was pretty useful. But other things are not, which is why, of course, as we discussed earlier, you need physical collections as well. And I've been looking at various physical collections in the University of Cambridge libraries. So, you know, these are useful in different ways because they tend to be more extensive. Very few have been made available online. This is just a search in our library catalog for Sudan. But they can also be problematic in other ways, in that, for instance, it's very hard to tell what they have here. So for instance, here you can see each of the sheets of this series are listed separately in a confusing way. A lot of the time, the way that we think about things geospatially is not how librarians think about things. So for instance, the collections I've been looking through at the University of Cambridge libraries, they are listed alphabetically by name, but that means that multiple different places in Sudan are listed under different names. So it's a nightmare trying to find them. But again, this is all kinds of things that you have to deal with. We've already discussed georeferencing, so I'm just going to go through it very quickly. This is a little bit more in-depth look at the georeferencing system. You know, you need to open your raster, you need to add the points. You can move them around. This is in QGIS specifically, which is open source and is generally the one that both our projects use most of the time. ArcGIS has its own particular way of doing things as well, which will be different, and then other GIS software as well will be yet more different. But yeah, you create a large number of GCP points. As you can see here, it's a long list of them. You transform them, you select the way of doing it. As I've mentioned, this map series doesn't have a known CRS, so I've had to kind of go for one that is used later on later maps of Sudan. WGS84 also kind of worked, but this one seemed to be a better fit. But there you go. And then eventually, when you set it all up, you start georeferencing. You can do it in the background on your computer, things like that. As mentioned earlier as well, there were a kind of multiple ways to decide what GCP points you're going to use. So you can use just the intersections of points. I know this is what Jack's already spoken about, but I think it's worth mentioning again. and then you can just enter those. You type them in. For instance, this is 2415. This is basically one to the right from the previous one. But you can also, as you can see on the bottom here, click on from map canvas and then select the points as was done before. And I found my maps series is much less forgiving than the ones that Jack and Afifa have been using. And there are much less useful points to use. I've been using mountains because they tend to be a bit better. The rivers are very inaccurate most of the time, or perhaps have changed. The village settlements are often very ephemeral in their parts of Southwest Sudan, so it can be very difficult to use them as well. And because the scale is is much larger, the kind of very small points that they're talking about, the intersections, are often very far off. So once you've done this kind of process, you can then sort of basically create shapefiles, which is the whole thing you do in GIS, draw around them, and then put them in Google Earth to see what you get. Is sort of the verification process. So here is, I've drawn around this old Turkish fort. As you can see, one thing you need to bear in mind when doing this sort of work is what counts as the point, right? So if you're on a very small scale, you could maybe even just use a little point, and then hopefully it will be in the same place. But on a very large scale, you have to draw a shape around it, and that shape may be very large in the space, as we'll see in a minute. And sometimes it's very unclear as to what is being referred to. So here we can see there's an old Turkish fort, obviously archaeologically interesting for us. But it's hard to tell whether that's referring to this little marker here, which normally would refer to this village of Damajevi right here. So I've kind of done it as a large polygon, and then you can zoom in, looking especially at this one area where it seems more likely to be because it's a reference to a specific point, but might not be. And you can see nothing because it's not there, because there's been so many problems in the process of seeing this that we're very clearly way off. And I mean, this point may not even exist anymore as well, which is another problem because it's been quite a long time since this was observed. There may be vegetation covering it. There are all kinds of other problems in trying to find things as well. So if we zoom out a little bit further, we can see that there's something that may be the fort, but which will require looking at possibly other imagery, things like that, in order to verify. And it is a whole kilometer away from the specified kind of most likely point. As you can see, the river was in a very wrong place, basically. And also, it's even further away from if we were using the text. So, this kind of situation creates problems, basically, is the first situation. And something else that can also create issues is, as I mentioned a bit earlier, is how you decide to georeference the map in the first place. So that these white lines here are based on just the points alone, if that makes sense, just the lines, not any real ground control points other than the coordinates given on the maps, because I've been lucky to have a lot of coordinates on those maps. Sorry, one sec. You can see here, this green circle here is the same well, but this is using a combination of a small number of the coordinates given on the maps, on the historical maps, and also a much larger number of ground control points based on natural features, primarily mountains, as I discussed earlier. But you can see neither of them really are particularly useful for identifying this mosque here, which is not really in the center of the text at all. And also, if you look here, you can see that this larger white square for the mosque, I have used the entire text. But as I mentioned earlier, sometimes the text written on the map describing the mosque will have a small point next to it, and you're unsure if that point is actually a reference to where the mosque is or not. So I've done it again, two different ways of doing it. In green, that's based on the point on the map, and the white is based on the much larger area, is based on the entire text describing the mosque. And if anything, the less specific one is better, because it meant I could search for the entire area. But it's such a large area was it really that useful at all for me to find things like this? You know, so the point really is that there are a lot of different decisions that you have to make, and how you make those decisions can really affect the process of eventually verifying data. And so, for instance, I mean, some of our data is maybe even unverifiable in any way. As you can see from this well, it's not a kind of very obvious where it is at all. So we again have problems of, should we include that data in our database? How should we include it? If so, things like that. But it's not all pessimistic. As I mean, Rene will tell you briefly, he's had a lot more success with his things. But also, I mean, some of this information, particularly we have this situation in a lot of parts of Africa, is completely unretrievable otherwise. So most of the parts I've been working on at the request of NCAM in Sudan have been in Darfur, where there's been almost no archaeological work ever carried out. There are perhaps 1 or 2 publications, not really very much. None of them really map anything. So this kind of historical maps data is basically, I don't know, irreplaceable in that sort of situation. And again, as it says here, some sites, even if they're mentioned as current at the time, such as wells, they could be fairly old. I mean, wells can exist for a long time before, obviously, they're mapped. And even then, it's quite a long time since then as well. And again, as I said, many map series are a lot easier to work with than this particular one. I'm just kind of providing a sort of idea of a lot of the problems that you can encounter. I have one final thing as well, which is a plug for our social media, really, where recently I posted about something quite cool that we found. We found this old fort in Darfur, again, something which is we might have noticed if we were doing systematic Google Earth surveying, but why would we have known to check this area, things like that. In this case, it's very, very recognizable on Google Earth. It wasn't very far off based on the historical map. And we know that it was old 100 years ago, and therefore is, you know, archaeologically interesting. But yeah, this is based on a post on our social media, so please go on and follow us there, and you can check in with how this work is progressing and how we're trying to deal with all of these issues. So I'm now going to pass over to Rene, who's going to go into a little bit more detail with his case study as well. But thank you very, very much for listening. And as it says here, ask any questions in the chat, and we'll talk about them afterwards. So thank you very much.
Thanks, Ed. Let me just quickly share my screen. Can everybody see it?
Yes, thanks, Rene.
Yes. Okay, good day, everyone. As Ed mentioned, I'm going to go into a bit more, well, not say detail, but I'm going to be looking more specifically at the type of historical maps that we're using in Southern Africa. So generally in Southern Africa, we have 3 types of historical maps that we use. We have the topographical maps that my co-presenters have also been going into quite detail. We have larger regional maps, which tend to date to the 18th and 19th centuries. And then we also have maps drawn by the explorers and scientific expeditions that came into the interior of the continent, also in the 19th century. Now, each map has its advantages and its disadvantages, and we get different types of information from the different types of maps. Now, the topographical map series we generally use is the 1 to 1 million that Ed mentioned, the 1 to 250,000, and the 1 to 50,000. Now, each one of these gives us different types of information, and depending on your question or your goal, you can use one better than the other. Now, as Ed mentioned, the 1 to 1 million series generally has very limited information, so we don't tend to use it that often. But sometimes what makes these maps quite handy is they have important features that are indicated but might not be as prominently displayed in the smaller scale maps. One example, as you can see there, is that the circle of the cross indicates the location of a mission station. Now, in Southern Africa, especially in the interiors, mission stations were very important features on the landscape during the 19th century. And as the full-scale social disruptions that occurred through this area known as Mafekane were occurring, a lot of communities fled to the safety provided by the mission stations. So finding these on maps can greatly help you to find archaeological sites in the area as well. Well, this specific site map is of the Kalahari area of Botswana at the Okavango Delta. And what makes these nice is also indicating the place of watering holes. Now, especially in the Kalahari area, these watering holes weren't stable, so they might have been present for 20 or 30 years and didn't disappear. So knowing what these locations are can also help you find settlements within these drier areas. The other one we use is 1 to 250,000. As you can see, it has quite a lot of very nice specific detail. The specific one is of the Eastern Highlands of Zimbabwe, covering an area that we know called the Nyanga complex. Now, what makes this map interesting is in the case of the Nyanga complex specifically, is it gives you different layers of information. Now, we know the Nyanga complex had 4 different types of settlements, and all 4 of these types are actually indicated on this map if you know how to look for. The one key feature of the Nyanga complex called forts, which aren't similar to the European concept. These were more areas where communities fled to for safety, not the specific military in nature. But as you can see, they are also indicated on this map. Just a few of them are highlighted in red. And then you have your general ruins, your general settlements that are also indicated. You can see there are quite a lot of them on the specific map. And then you also have your more historical features. Now, this field museum, although it is a modern creation, was already built in the 1920s. So when this map was drawn in 1970s, it was still there, and today it is a historical site in its own right as well. Then another feature of the Nyanga culture that's quite unique to them was the location of pits within the middle of their settlements. And these are also indicated on the map as pits. So although you need a little background in archaeology to understand the significance of the pits, these themselves are also indicating the location of settlements. And then you get some more general information, like for example, there, the ancient terracing. The Nyanga complex is renowned for their extensive terracing covering thousands of kilometers, and the entire mountain ranges in this area are completely covered in terracing. And if you look closely here at the area called Hunikak ruins, which is today called Ziwa, you'll see there's only one indication for a ruin there. Now, this is important for the next map. So the next series that we use is the 1 to 50,000, which is a lot more detailed. And again, you get similar information like the location of sites. But as you can see in this specific one, sometimes on the 1 to 50,000, you get more information than you would on the 1 to 250,000. And the case that this one indicates 2 more ruins. However, what you should keep in mind is that on these maps, not all archaeological sites, even in the known area, will be indicated. This area, if you look at the boundary lines here, indicate the boundary extent of the Ziwa National Monument in Zimbabwe. And this area just viewed here actually contains over 500 settlements, and only 3 of them are indicated here. So these maps are a good place to start, but you should always keep in mind that there's most likely a lot more on the landscape than is indicated on these maps. And then you also have your normal other information like the historical monuments and that. And what makes these maps nice, if you have different series and different periods, is you can also use them to match each other to see whether which one is more accurate. Is there a large discrepancy between them? Has the site potentially been moved? Because especially in Southern Africa, we often have sites of the same name being moved to different locations. And these maps can help you also pinpoint movements like that. And then you also have the terracing that's also mentioned on the 1 to 250,000. Now, a lot of has already been said about the accuracy of topographical maps. I'm not going into too much detail about that. I would just like to point out that accuracies on a map can differ even if the map itself is accurate. If you look at this area known as a drift, there you can see on the topographical map to the top left, top right, and the bottom, the overlay on the satellite image, the 2 of them match very good. These rivers are not wide, so you do have a lot of sandbanks developing, but you can see there's a very good overlay there. Again, the section of the curve of the river, you can again see there's quite nice overlap between the topographical map and the satellite imagery. However, if you just go a kilometer to the south and this bend over here, you can see there's indicated on the historical map, but if you look there, it's quite a distance away from the actual river. Now, these are granite hills, so this river valley hasn't moved, so the river course hasn't changed. This is just simply an inaccuracy on the map itself, which is not the general inaccuracy of the map type. This is just an error that was made on the specific map. And then human-made features can also vary in extent of their accuracies. Now, on a 1 to 250,000 map, you do expect some degree of error. So this is an example of a Nyanga fort, which I mentioned earlier. And this is the fort on the map. It's called Chawamba Fort. And if you look at the bottom here, this is the area located after being georeferenced, where the map indicates the fort to be. However, that is the location of the actual fort. So in this case, we have a 200-meter error between where the map said the fort is and the actual location, which on a size scale we're working with is actually surprisingly good. Some of our sites have larger errors, some of them have smaller ones. Then we get to the regional maps. Now, these were maps typically made covering the whole of Southern Africa. Most of them cover the territories of Namibia, Botswana, Zimbabwe, Mozambique, South Africa, Eswatini, and Lesotho. And they give you an indication of the historical development of the area, as well as how information can change over time. Now, as you can see, these two maps, 1828 and 1836, the red dot here indicates the mission station Kuruman, which was the starting point in this region for all the expeditions that were heading into the interior. And the circles around here indicate Kurachani, which is a very well-known site in the 19th century. You can see the difference in information that you're starting to get as more and more expeditions are going into the interior. The information start getting filled in. Again, 1854 and 1872, the same region with Kurachani there, Kuruman there and there. Again, you start seeing more and more information. However, one thing you should always keep in mind with these regional maps is where they themselves also got their information from. Because often these maps build on older maps to get their information as well. So in this case of the 1836 map, and 1854 map, they actually used the same source to draw some of their maps. As you can see, this line here is the route of a famous explorer in Southern Africa called Archibald. He was one of the first to explore the region. And this route is also indicated on this map here. What this indicates to us is that both these maps used either his journals or maps drawn of his expeditions to get information from their specific maps. What this means is inaccuracies inherent in the one automatically get transferred to the other as well. And just to highlight the route a bit more clearly, you can also already see the difference just in the route itself and the course of the rivers between these two maps, even though they cover the same area with the same information. So these are errors and inconsistencies that you'll just have to keep in mind when working with these types of maps. Then the last type we generally use is your first-hand accounts, and they generally fall into two types of maps. You have the maps drawn by the expeditions themselves, as illustrated by this one. And then you also have the first-hand account maps drawn by the authors who published the accounts themselves. To the right is a famous one of the missionary Robert Moffat as he went to the Matabele Kingdom. And the right is also a famous one by a scientific expedition of Andrew Smith. Now, each one of these maps are valuable in their own right, and each of them do also have errors inherent. The advantage of the third-hand accounts that have maps drawn while the expedition was occurring is that you get a more detailed route that the expedition itself took and the areas that they visited, which can become quite nice if you're using this in conjunction with the first-hand account to track down settlements mentioned in the accounts. They also often give you information of other expeditions in the area, which you might otherwise not have known were there. And this allows you to track down additional information for the area that you're interested in. And the ones drawn by the publishers, although they tend to be more accurate in their geographical display, also have built-in inaccuracy because they just simply connect one part of the map to another one. In this example here, you can see the black line is the route of Andrew Smith according to the author of the publication. Yet the red line is the actual route the expedition did based on a systematic reconstruction of the route based on their first-hand accounts. So each of these are useful in their own right, but the problems and inaccuracies should be kept in mind when using them. You can see there the error difference between that section of the route where other sections match up quite nicely. So we have a very different types of sites that we can identify from these historical maps for use for our projects. The one, as I was already shown you, was the example of a Nyanga fort, which is clearly visible on Google Imagery, although you don't always know where they are. So having them indicated on a map can greatly speed up the process of finding them. But other sites, like rock art sites, you might not know exist at all unless you physically go into the area. So having them indicated on historical maps like this makes it quite handy to find them because you will not be able to locate them from satellite imagery. What another nice thing about these historical maps is they can also help you track down sites that have been destroyed. So that allows you to document them and reconstruct the historical landscape, even though the site's not existing anymore. A nice example of this is in the Eastern Islands of Zimbabwe. If you look at the red dot, that's the site indicated on the historical map as being a pit ruin. And as you see there, there's a slight bit of development occurring next to it. But in 2009, the red dot again illustrating the site, but you can see the development is starting to increase as well as to the south of it. And unfortunately, by 2013, the entire site was overlaid by farming and a large section of it has been destroyed. Now, if this site wasn't documented on a historical map, you might still have been able to find it in the historical imagery, but depending on the quality of the historical imagery and its availability, sites like these might be lost if you use only satellite imagery, which makes historical maps also useful to track down sites. Other types of sites we can indicate, find like this is the Z1 National Monitor I mentioned earlier that only had that one dot on a 1 to 250,000. So this is a satellite image taken, and all the circular structures you can see here, those are actually settlements. They're known as pit enclosures. And then you also have the terracing here. And as I also mentioned, there's often a lot more in the landscape than these maps indicate, even if they tell you they are ruins. And this is the area just further to the south. Again, you can see all these circular features which indicate the settlements with the terracing. And these weren't indicated on the historical map at all. So although the historical maps are quite useful, you should always keep in mind that they're often also limited in the information they give. And then another nice example in the Nyanga area is further up in the highlands, known as the pit enclosures. These were the earlier settlements of the Nyanga culture. And here you can see them quite nicely. There is the pit with the feature around here where the settlement housing would have been. There again with the terracing. And what's nice about the specific one is it was indicated on a historical map. And the area surrounding this map has a lot of depressions, which on first sight just look like natural features. But knowing the archaeology of the area and the fact that this ruin was indicated as a ruin, we now know that these depressions are actually the remains of pit structures in their own right, which indicate that this area had an extremely dense settlement period, with almost 100 pit structures being found within a 5 to 10 kilometer area. So it was quite densely occupied for a very short period. The historical maps will kind of help you not only reconstruct the landscapes in the past and help find these sites, but by tracking how they change, you can also reconstruct population movements in the past and also how these sites will now be impacted with modern development. Thank you.
Many thanks to Ed and Veneer for their wonderful presentation on historic maps in Africa in general, the type of different maps and how they're used in MAEASaM's projects to identify any possible sites. If you have any questions, please, you can either raise your hand, or if you haven't typed already in the chat box, you can type them in the box. There was a comment from Felipe that Faye provided an answer to it, but it was a question to Ed asking about the crowdsourcing. So Felipe, do you want to ask your question, and we can see if Ed has any also thoughts to add on this point, and whether these locations are accessible for local community to provide any information.
Hi Ed, it was a really interesting talk, and I was just wondering this aspect of the possible crowdsourcing. Of like not necessarily going there, but like engaging with the people who live in the area that might actually provide a more accurate description of what are around, especially that you're showing that a lot of these are like fairly big ruins or structures. I thought that this could be a possibility, but I don't know like logistically how that would be feasible. So it's just like an idea as well. Don't know if it's something that you're looking into it.
Yeah, so we're still in the process of finally sorting out our agreements with the various countries that our project works with. So I think probably that seems like something we would need to kind of wait for that to be determined. It does seem it's definitely very interesting, and as Faye said, I think it could be an option. I agree with Faye. It's, as you say, there will be logistic constraints with that. So I'm not going to firmly say whether or not we can do it. I would say it would be difficult, but I think it would definitely help us with a lot of the problems we've encountered in terms of very specifically getting things down. I mean, I know that things to do with, I forgot to mention this actually in the presentation, but I found as an example of the kind of volume of data that we can get, when I've been looking through the Darfur area and kind of adjacent areas of Sudan, if they're included in the map, I've got over 1,600 different points of archaeological interest from just this 250,000 series, and there are more series that may be interesting in the future. But yeah, but my point was almost all of them, probably over 2/3, are wells, which are pretty difficult to verify. So yeah, I do agree that crowdsourcing could really help with things like that, in that you can just ask people if they know where the local well is. But it's, yeah, I'm not going to firmly say as of yet. But thank you very much for the question.
Just quickly want to add, Felipe, in Southern Africa, community involvement, or speaking with the communities, are quite a critical part in the research process. And a lot of our very well-known historical or archaeological sites were actually found thanks to the local community informing the researchers that these sites were there. So in Southern Africa, it is quite a well-used and important part of the research project.
Thanks very much. We have 2 hands up. Kazala was first, and then we'll see with the time. We might need to answer Hamid's question in the chat, but let's see, Kazala, if you can go ahead and quickly ask your question, please.
Thank you very much. My question is very simple to Renia. I'm doing a study in Zimbabwe on the Great Zimbabwe Culture Site, and basically I'm trying to do some kind of field work. So, but then I'm very interested in the historical maps. Would you kindly help me how I would deal with using field research and these historical maps as well, and in terms of what kind of methodology should I use towards the use of historical maps combined with field work, and also combination with satellite imagery?
Okay. For your type of research, it will be quite interesting to see, because the Zimbabwe culture, because it's so old, a lot of it actually predates the historical map period. So it will be quite interesting to see your results. Now, standard methodology that we use when combining these methods like you discussed is, the advantage of being able to use field notes is that you know of the physical sites that do actually exist and you know where they are. Then what you can do is you can see if any of these sites that you know do exist are present on any of the historical maps that you have. And this, what makes this useful is you can use the physical sites that you know of as sort of anchor points for your historical map. So as you know where the sites you do know are, where they're located is, and how they are represented on the historical map. This will tell you the complexity of the map, its accuracy, as well as the type of sites mentioned. Then when you have this information, you can start looking at the other sites also mentioned on the map. And by using the accuracy you now know, you can translate that over to something like Google Earth, and then look in the areas where the map indicates the ruins will also have been present. Now, because you know the general inaccuracy or accuracy of the map, you'll be able to compensate for the error placement and then narrow down this search on Google Earth. Luckily for your area of Zimbabwe, there is quite a lot of historical imagery also available on Google Earth. And this is quite important to go through the historical imagery because you have changes in vegetation, especially in the drought periods where a lot of the settlements will actually stand out quite more than they would in more recent ones due to the rains. And some of the satellite imagery also have contrasts built in, which also makes some of the settlements come quite nicely. So what a best way to approach in that case would be is always use the field notes to sort of give yourself a foundation of how to read and interpret the historical map. And then from there, go to the satellite imagery and see if you can find the sites mentioned on the maps.
Thank you very much. I hope I could also get in touch with you for more in-depth knowledge.
Please feel free to contact me at any time.
Thanks very much. And just very quickly, Hamid, if you'd like you to ask your question, but very quickly as we're running behind. Thank you.
Okay, thank you. I'll try to be short. My question is for Rani. I would like to know about the significance of historical maps in the identification of rock art or rock carvings, and plus also in identifying the ancient routes which were used during that particular period.
That will depend quite extensively on the specific map you have. The map series I illustrated for Zimbabwe does actually illustrate quite a large amount of rock art sites and rock engraving sites on them, which does allow us to find them via satellite imagery. But again, that depends on the map. Some of the South African maps don't do this. So if you do have a nice historical map that indicates this, they can be quite handy to find. What I've also found is the first-hand account maps. If you're able to correlate the first-hand entry of the maps generated, and they mention rock art sites or engravings, such as the route of Andrew Smith, you can also find those sites via the map that's published and the route account, which will help you to find sites that, unfortunately, as in the case of South Africa, has already been destroyed. As to tracking down the historical routes that were used, these maps are actually historical, especially the regional maps, are quite useful in this regard, because a lot of the maps were drawn by information obtained from explorers and traders who went into the interior and came back. So they automatically included the routes they took on their expeditions, which the map creators then incorporated. And in your drier areas like the Kuruman region, all the explorers and expeditions use the same route. So you can actually reconstruct the routes and the trading routes via these maps, depending on the region. The eastern part of Southern Africa isn't as extensively covered. Now, as to finding the historical sites and the ruins, these maps are quite important. One of the most famous sites discovered in the last 20 years, Kuruchane, was chiefly discovered by the use of historical maps and first-hand accounts. It was a very large settlement consisting of 2 sections, and now that we know where it is, you can see it on Google Earth satellite imagery. But it was completely forgotten up until the 1990s, until it was rediscovered by using these 2 methods, because unfortunately the site was destroyed in the 1820s during the Mfecane. So it does help quite a lot to find the ancient sites.
Okay, thank you. Thank you very much. It's really helpful.
Thank you very much. And as we're running a bit behind, so quickly, I want to present our last speaker, Ivan Berganzo. He's from the Catalan Institute of Classical Archaeology, one of the partners of MAHSA project, and he will be talking to us about machine learning. Because as you could see from the presentations up until now, extracting sites manually from these maps can be both time-consuming, and people have different methods and way of finding features. So he's going to talk talk to us about how automatically these things can be done. Ivan, I'm sorry for the delay. As I told you, you can use an extra 5 or a few minutes after, and we can adjust in the end. The floor is yours. So if you can share your screen.
Just let me.
Thanks very much, Ivan.
Okay.
Yes, we can see your screen now.
And do you hear me?
Yes.
Perfect. Now full screen?
Yes, it is full screen. Thanks.
Okay, perfect. Okay. So, okay. Okay, so my name is Ivan Berganzo. I am PhD researcher from the Classical Archaeological Catalan Institute, and I will introduce you to machine learning and how to use it in on historical maps. I will talk about the artificial intelligence, machine learning, its algorithms, how to use it in archaeology, and about how to detect on historical maps. Okay, so the first question is, what is the artificial intelligence? When we talk about it, we have to go to 1956, where it's the first time that this name was coined. And when we are thinking about, we think maybe that is more like science fiction one, no? As you see, this intelligent robot, but this artificial intelligence is called general. It's not the common one. It's not the one that we have nowadays. This is called weak. And what's the difference? The weak one is the real one, because thanks to machine learning, we arrive to make automatization and speed in our algorithms to have something similar to artificial intelligence. But not only thanks to the machine learning, also thanks to the electronics, such as graphic cards, GPUs, and so on. And the alignments that the highlights that we achieve are in automatic speech recognition, natural language processing, and in computer vision. The last one is one of the most interesting for us because it's the one that is more useful in archaeology. So is it the machine learning, the thing that we were thinking on, this intelligent robot, or maybe it's more like an algorithm that learns from our data sets? I think the question is more for philosophers, and we can continue knowing at least how to work with machine learning. So how do the machines learn? This is our data set. For example, all this data of the maps that we are talking today about. And the first thing we have to question about is with what language we will make to the machine learn. This is the program languages that we are common using it. The first one is Python, the second one is R, MATLAB, and Lisp. But we also have to take into account the modules, the libraries that we have to use to program in machine learning. This is TensorFlow, Scikit-learn, Keras, OpenCV, NumPy, Matplotlib, and Pandas. And at the end, where we can program it and use it. We can use a Colab environment that use Jupyter Notebooks to program our algorithms of machine learning. So let's go. We will make to learn a machine. So what have to do? And what have to do? We have to divide our dataset in 3 types of dataset. The first one is the training data, that must be the 50% of the whole data. And then the rest, 25%, is data to validate and test our algorithm, our training algorithm. So here you see that we take our training data and we have a model, a machine learning model that is an algorithm. Now we train our model with this training data, and we at the end have an error less than 0.05. We call it loss, but it is an error. If we have an error less than this, it's a good error, so we can continue with our algorithm and evaluate it. How we do evaluate? With the validation data. We pass the validation data to the training algorithm, and we will have some false positive and some false negatives. So if we score it, and the score is low, we have to retrain our algorithm again. How we do that? Was maybe adding more training data, data augmentation techniques, and changing models parameters. And then again, we train with these new techniques, and we again have an error less than 0.05. Then we evaluate the training model again, and now the score is higher. So now that is high, we can make the second evaluation. Now, not with validation data, we use the test data. And again, if the score is high, we can use our training and validating model to detect other data that we know, new maps, and that we don't use in the training step. And after detecting it, we will make prediction classification with a lot of accuracy. So which types of machine learning algorithms are now using in this field? The four most used ones are the linear regression, random forest, clustering, and deep learning. The first one, linear regression, is about correlation between different data. It's a supervised algorithm. We know the outputs for our inputs in the training data set, and we make predictions for new input data. So we will see a real case. It's about the diffusion of Gravettian technocomplex in Europe. And the hypothesis of this case is that one of these three sites may be the origin of the Gravettian. So the people who make this paper take off the data of the distance between the sites from these original sites and the appearance of the Gravettian in these sites. After training the algorithm, they obtain this line that is a correlation, a comparison between the distance from this original site and the data of the Gravettian in these sites. As you see, the R value, that is the correlation value, is a little bit low, it's 35%. This another one is from the second site, the Hessens cluster, and has a better correlation number. And this last one has again a lower correlation number. So which one is more likely to be the origin of the Gravettian in Europe? The Hessens cluster site, because it's correlatively much bigger. So after doing this, now we can say, I found a new site that is an X kilometers from the original one. And using this algorithm, I can predict which is the data of the Gravettian in this site. This kind of techniques, low cost, and for example, we can know to do the radiocarbon analysis, because with only this algorithm, we have more or less the data of the Gravettian in this site. The second algorithm is the random forest. What's about? It's about decision trees. These are questions that we make about the features of our dataset. It's again a supervised algorithm. We know the outputs for our inputs in the training dataset, and we make prediction for new ones. A real case is a paper that will be published more maybe this week because it's accepted, and it's about detecting tumuli and whenever you want, but here is applied in the northwest of Iberia. The hypothesis of using the random forest is that we want to classify the soil into areas suited or unsuited for the presence of tumuli. And we use for dataset more or less 4,000 sampling points for Sentinel-2 bands. And here, as you can see, we have 1, 2, 3 the points that its features are the class if it's suited or not for tumuli, and the bands, the values that this point has in these bands. So this is our features for our points, and we make, or the algorithm made a decision tree question about these values, and then we obtain an image where we can see the places that are suited for presence, the black ones, and in red, the unsuited. So now we can search better the tumuli in the suited areas. Another algorithm is the clustering one. The idea of this algorithm is to group dataset objects according to their similar features. Why is that? Because it's an unsupervised algorithm. Here we have not the outputs, so we can compare with the desired ones, the prediction that we made. But the algorithm look for patterns in the input data, and then finding these patterns, it can classify the dataset objects into different clusters. To see it better, we will see the real case, that is the application of clustering techniques to group archaeological artifacts. And the hypothesis is we can restore ceramic amphoras and glass vessels from fragments. And the dataset that they use is the chemical elements of these fragments. So here again, we have 1, 2, 3 fragments that we don't know which amphora correspond to, and we take the data. After using this clustering algorithm, the algorithm itself will separate in 3 classes all of these fragments. And now we have that in real, we have 3. I don't know how to appear this. It's about, sorry. Do you see a red line in the screen?
Yes, I think it's an annotated function.
Sorry.
It's okay. It's gone now.
Sorry.
No worries.
Okay. Now we'll continue with the last one, that is deep learning. It's based on neural networks. And as you see here, this is the first neural network made by Frank Rosenblatt. That it's quite complicated, but the key of this algorithm is the feature extraction. What is that? I will show you an example. These are Greek columns, and as you know, the first one is Doric, Ionic, and Corinthian the last. The features of these columns are, for example, the base, the material, the decor, pollutes, and vegetation. This is the data that in the traditional machine learning algorithms we must seek, because this is the data that we pass to the algorithm. But now in deep learning, we just only use images like this picture as input data. And we don't say which are the features, because the algorithm will log we look for them by itself. And maybe you think these features were better, but the algorithm will decide that better are others. So to understand it a little bit more, the deep learning, we will explain 3 types of algorithms that they are using the learning. The first one is multi-layer perceptron. But what is a perceptron? To answer this question, first we have to answer what is a neuron. A neuron, that is a perceptron, is a combination of the input entrance of the input data that, after applying a multiplication of weights that are numbers, we obtain an output. If we translate this neuron to a neural network, we will see that the neurons will be connected one with the others. And if we make a training, for example, the information will go from the input data, the layer, to the other layers, like in the image. And then when it arrives at the end, as we talked before, the error is calculated with a loss function and will go again backwards, changing the weights value. Because in the next iteration, the weights will be more correct than in the previous one. And iteration after iteration, we will obtain the good results with low error. To see this better, we will see an example that I have here. It's made by Google. And as you see here, we have a neural network. Our training data is are points. Are points like these ones that are blue or orange if they are in one position or in other. Here we have the X and Y position in this table, and we will train the algorithm. And you will see in the background of the image how the algorithm fits to the points. As you see here, we have the loss that now is 0.4. And here at the top, we are seeing how the epochs, that are the iterations, are going on. And as you see, the background, that is the algorithm really, is fitting with the orange in the orange points and with the blue in the blue points. And as you see now, the error is 0.1, 0.04. So now we can stop it. And here we have the algorithm trained. So now if we use another new data, another points that we don't know its class, if they are orange or blue, the algorithm itself will say if they are orange or blue because it's trained. So this is how a neural network works. And the multi-layer perceptron. The next algorithm is the convolutional neural network. What is the difference between the convolutional one and the multi-layer perceptron? The only difference is that we are at the beginning a convolutional layer. This layer will allow us to detect local patterns versus the global ones. And how does the convolution works? As you see here, we have 3 images. The first one is our input data, that is a 7, and the convolution looks for the local pattern, the border from objects or the more significant information. And then we make a group of this pixel to use the same important information, but in less size. And then this pooling is the one that will go through the neural network, as we see previous example. Two types of convolutional neural networks are, first one, the object detection. Why? Because we can find the local pattern, we can search inside the image for the object. For example, here we have an image where there are 3 tumuli that are the white circles. If we use our trained and validated model to detect these tumuli, we will obtain their position in the images. And the algorithm that we use to make these convolutional neural networks for object detection are YOLO, faster RCNN, and efficient depth. This is the newest one and the most efficient. And the other type is not only to detect the object, is to segmentate it. Why? Because if we are interested in their shape, like in this image, we have ceramic potsherds, and we want to know not only where they are, we want to know their shape. So after applying this algorithm, we will, as you see in the color potsherds, not only where they are, we want to learn its shape. And the algorithm that we use to learn this is the MAHSA algorithm. And the last type of algorithm in the learning is the recurrent neural network. This is quite different because it uses sequential data, because it has the dimension of time. It's based on recurrent neurons, that is the same neuron that we see before, but with a feedback loop that it uses its entrance, but also the previous ones. So now we can decide whether the next prediction because we know all the previous input data. And the backpropagation is a little bit more complex, the way to update the weights. A real case is the Beethoven X. That is a work that appears the last week, where they finished the Beethoven's Unfinished Symphony number 10. For the dataset, they use all the Beethoven's music sheets. And what they use is only the beginning of this symphony to finish all of it. As you see, the music is sequential. It's important, the previous notes, to predict the next ones, not only the first before one. So to finish it, we can say, after knowing what is learning, what is machine learning, how to detect archaeological feature on historical maps. As we see before in the previous speaker says, this is a mound in a map, and we want to detect them. So first of all, as we see, here is an image, and the mound is in a position that not correspond with whole the image. So we need to feature extraction. That means deep learning. We need to find local patterns. That means convolutional network. And as we are interested in their shape, we need to make segmentation algorithm. So after all of this, which is the algorithm that we want to use for finding mounds in historical maps? MAHSA algorithm. So this is the bibliography that I have used. And thank you very much for your attention, and I will be answering your questions. Here you have my email, the Twitter accounts, and that's it. Thanks.
Many thanks, Ivan, for this very informative presentation. There've been a lot of information here, but we're happy that this presentation is, all the workshop is recorded, so you can have access to the link and you can follow on your pace. Now, if you have any questions, now it's the time to ask. I see that we already have one question from Pamela. Would you like to unmute yourself and read out loud your question, Pamela, to Ivan?
Thank you, Zade. What I was asking, one of the methods, I think the first one that Iban has talked about is the use of linear regression for detection of archaeological sites. So my question was, given that archaeological sites don't necessarily depend on, ecological patterns or physiological earth sort of formations, maybe they do, I don't know. But I'm just thinking in terms of they are more of cultural and heritage kind of factors that lead to their being established in certain places. So how effective are the linear regression methods, which essentially rely on physical explanatory factors, like you want to list say they have to be close to a river, or they are located in soils of a certain type, and things like that, which may not necessarily be where archaeological sites are detected. In that case, how effective is linear regression, and especially when now they establish a correlation of say 0.5 or 0.6 or whatever it is, that this is, it essentially is like causality, you're trying to establish a cause for that archaeological site being located in a certain place, and yet you have a lot of other factors that are not physical or physiological or ecological that determine the location of archaeological sites. And in that case, then isn't it wouldn't a lot of post-processing be required, field work for verification and so on? Thanks.
Okay, thank you very much for the question. Yes, as you said, it's important to have a lot of data, because the algorithm, in this case the regression one, will search for correlations. If there are no correlation in the whole data you pass, the algorithm will say that the correlation number is very low. So this is not a good algorithm to use for this data if you don't have a high score. But as you say, you can use a lot of type of properties or parameters to try to search for this correlation. And at the end, when you finish with the detection, of course you can go to the field and check if it's correct, because this is another testing, no, that you can make to verify your algorithm.
Yeah, I just wanted to add that we are not using regression algorithms. We are using classification algorithms, because we are not predicting, but classifying our input data into sites or not sites. And we are using regression for other stuff, but we are not talking about it today. And yeah, as Ivan says, it's pretty clear that sites have a lot of different characteristics. And our approach to site detection now is to use as many of these characteristics as possible, not just their shape. I mean, the paper Ivan was talking about, this hybrid machine learning we have developed, is using multispectral, but also radar, is using also the shape of the site. So what we are trying to achieve, it's a definition of sites using as many characteristics as possible. And it's working pretty well. We don't use linear classification methods because they are too simplistic. They really don't work. I mean, you cannot classify. It's very difficult to differentiate sites from non-sites with a linear classifier, because it's data, I mean, the definition of a site is usually much more complex and wouldn't fit in a linear model. Okay, so yeah.
Thank you so much.
Thank you very much. So I couldn't see another question in the chat. If you have more questions, please you can email to us, and we're happy to answer them. And if you have, I think we have time to answer another question. So if you maybe raise your hand, we can answer another question to Iban. Kezola, is that a new hand, or is this from your question before? I see your hand is up.
It's a new hand.
Yes, I'm sorry, please go ahead.
Okay, thank you very much, Ivan. I'll go quick with my question. I'm trying to use deep learning with PyTorch, but then one of the issues, problems I have is that I first have to label the data on the satellite images, and then after I label, then I'll try to run the verification and all that. But then now I'm interested in combining historical maps with satellite imagery. Is there a possible way I can use those, train the data, and then somehow use it for example, if I'm trying to recognize new sites, train that data to recognize new sites on either historical maps or a combination of historical maps with satellite images? I don't know how you would advise on that.
Yes, as you said, you can use whenever the input data you want, historical maps, or you can add more layers. The much bigger problem that you can find with this is that maybe the computational cost is a little bit higher. So it depends on your resources. As I said, you can use a collab environment to train your algorithms and then to detect. But you have to take into account that it's a free resource, but it's not, I think you can work with it 12 continuous hours. So you can try it, but take into account that you need a good GPU and good other resources.
Thank you very much.
Thanks very much, Ivan. So now we came to the end of this 4 and some hours workshop, and I want to thank you all again for joining us. I want to thank the speakers and also thank you to my colleagues, Rebecca Roberts and Chris Matthews, who's been, and also Faye, and they've all been helping with answering questions and admitting people. Thank you all. So with today's workshop, our aim was to provide an overall understanding of historical maps. We tried to cover many different, both how to use these maps, or what are the methods to use to analyze this map. And also we went to some technical parts of georeferencing using Quantum GIS, and also the machine learning part to how to better understand the past landscape and identify and detect possible archaeological sites. In order to facilitate this knowledge sharing, we thought it would be very useful to make quick or short guidelines on how to better understand these maps, what are the information that you find on the maps, where are the repositories, and what are the different iconographies on each maps. We've developed one for MAHSA, and the one for MAEASaM is under development, and I will share both the links with you. But I want to share the link for the one that we have for MAHSA, and I lost the chat. I'm trying to find where is I minimized it. Okay, I'm gonna add the link, or maybe if Junaid, I think Junaid has a link to the drive, so we can share the link with you. And I can quickly share my screen here. So this is mainly how it looks like. So it's a very brief and simple overview of the maps, and this one is specifically for the Survey of India maps. And what are the iconographies about the archaeology, different types of mounds, and any different heritage that you can find information on the maps. Where are the repositories, and mainly the repositories that we have in the UK, they are listed here, but we're gonna provide a link to the a live working document that you can also use that to add any repositories that you know in different part of the world, so we can build on this documents. How to read and understand the maps, this was part of also Junaid and Afifa and Jack's presentation as well, and what are the information that are available on the map, with a very brief section at the end with the extra sources and extra readings. Yes, now I want to just run the poll. This is very strange. Okay, so I can see it here. So there are the two questions that we asked you at the beginning of the poll. So if you can ask those questions, and also there are a few extra questions to understand better your needs or your preference for any future workshops and trainings that we're going to hold in the future. So if you can take a time before you leave to answer this poll, it will be very helpful for us. And thank you again. When you're done with the poll, you can leave, but if you can, I think you should be able to see the poll now. And thank you all.